حياكم الله في رحاب جامعة الملك خالد وفي عسير القمم والشير. نلتقي اليوم تحت مظلة مؤتمر الحلول المستدامة في الطاقة والبيئة، مؤتمر ينطلق من روح رؤية المملكة.
It is my honor to welcome you to plenary session number 3, recycling. Today we are privileged to hear from leading experts who are advancing innovation and circular economy, waste, valorization, and low carbon technologies. Ladies and gentlemen, our first speaker is Prof. Long Neem, Director of Center for Technologies in Water and Wastewater at University of Technology in Sydney, Australia. Today he will present a talk entitled Scaling Up Microalgae-Based Carbon Capture. Prof. Long, the floor is yours.
Assalamu alaikum. Good morning. And before I begin, I would like to express my gratitude to the organizing committee for giving me and delegates of this wonderful conference Saudi hospitality. I really appreciate that. And I also want to thank you for giving me the opportunity to share with you some of my team's latest research results on carbon capture using microalgae. Next slide, please. So over the next 25 minutes or so, next slide, I would like to do a couple of things. I first want to explain the background why we have embarked on this journey and looking at using microalgae as the platform for carbon capture. What is the roadblock and what we have done to try to resolve that block. Can we go to the next slide, please? So we all know about climate change, and I guess everyone agrees that we have to take some action addressing climate change. In fact, Australia and Saudi Arabia are very similar in a lot of aspects. We're both in a very dry climate, a lot of sunlight, not enough water. Most of the landmass are desert land. Relatively low population for the very significant landmark that we have. So the opportunity is there for us to utilize the abundant sunlight. And of course, both countries are very rich in energy. Here in Arab Saudi, that is oil, and it is coal in Australia. But we are not actually taking that for granted. We need to use our advantage so that we can transition into the new future. And that's what we have done in Australia as well. Next slide, please. So if you look, next slide. If you look at the video on the screen there, and that is a microalgae. It's actually a single cellular bacteria that can multiply very, very fast. It only takes about 5 hours to double or to reproduce. That means in about 2 days' time, it will multiply by more than 1,000 times. So it grows really, really fast. and the energy is actually from sunlight with a tiny bit of nutrient that should actually be quite readily available from things like wastewater also. And that actually is the platform we utilize from Mother Nature in order to scale up the ability to capture CO2 from the atmosphere and bring it back to beneficial use. Next slide, please. And if we look at the microalgae industry, it is already an industry by itself. Most of the cosmetic you are using nowadays would have some contribution from microalgae. Many of the food you have come from microalgae. Nutraceutical is from microalgae. It is a $1 billion industry. However, so far the production of microalgae is very much limited to the few products that I have mentioned just now. And the key challenge is in the harvesting of microalgae and in intensifying the production of microalgae at very, very low cost. So if we produce microalgae for cosmetic, $100 per ton of microalgae is reasonable. But if we want to use microalgae as a platform for carbon capture, we really need to look at a very much different economic equation. What we have estimated is $1 per kilogram. So it's very, very low in production cost, that what we need to achieve. And the key bottleneck, next slide, please. The key bottleneck in achieving what we want is basically in harvesting. So for us to obtain microalgae as the end product, we need to first cultivate. Now, we actually done quite a fair bit of work on how to intensify the cultivation of microalgae, but I won't be talking about it today. The next step is, once we have a mature microalgae cultivation, we then need to separate the microalgae biomass from water. Now, at maturity, the microalgae solution only have about 1 kilogram per cubic meter or 1 gram per liter, which is still very, very low. And we need to do that separation. Then after we get the microalgae biomass, we then need to then do further processing to convert the biomass into valuable products. That is another part that I will not be talking about. So today I'm going to squarely focusing on how do we lower the cost of harvesting and scaling up the harvesting process. Next slide, please. So what we have done so far is basically, next slide, please, to look at the challenge. Yep, next slide. Right, so the challenge in microalgae harvesting is because microalgae, they are individual cells to take sunlight to grow, and therefore they want to be dispersed in water. So nature have given microalgae two very distinct properties. Number one, they're usually very small, usually micron in size. Number two, they are negatively charged. And the reason why they're negatively charged is because charge repulsion will keep them apart. That allows them to be in suspension in water phase and maximize their ability to uptake sunlight. Now, we need to overcome that. And the way we have addressed that is basically to do exactly the opposite. First, we need to look at charge neutralization. So we need to then somehow manage to remove that negative charge. And then we need to be able to bundle all the individual microalgae cells together. And therefore, we have invented a polymer. The polymer is large in molecular weight, positively charged, and it acts like a spider web, that when we add it into the mature microalgae solution, it will aggregate all the individual cells together, neutralize the charge, and then we can pull them up from the water phase. There's another challenge that we have to look at, that is how do we minimize the consumption of that polymer that we have created. So essentially, over the next few minutes, I'm going to present to you two breakthroughs that we have achieved over the course of 2 or 3 years. Next slide, please. So if you look at the video, you can see how powerful our polymer is. There's a tiny bit of polymer adding to a microalgae solution. You can aggregate the microalgae, and you can then simply pull it out. Now, we then scale it up into a pilot system where you can see that we add the polymer. We basically have a flotation system. The microalgae can then be recovered through a conveyor belt. And then at the other end, we have microalgae as a paste. And all we need to do is to use a little bit more thermal energy to dry it. And then we have microalgae powder, and then we can process it further. So it worked really well. Let's stop at the first, pause at the first breakthrough and explain to you a little bit more detail before I go to the second breakthrough. Next slide, please. Next slide. So the polymer we have, as I mentioned before, is made of basically an acrylic functional group that gives it the positive charge, and we can tune the molecular weight. So we actually patented the process of making the polymer because we can tune the polymer for any given microalgae that we have. Now, the way we produce the polymer is to use photopolymerization. So in the process, we start with a photoinitiator. We have a monomer, and then we have the quenching agent to remove all the oxygen in water. Now, if we have oxygen, it will interfere with the polymerization process. So then, the parameter for us to control become very simple. The energy of UV radiation and the polymerization time, plus the actual monomer that we start with. So if we increase the polymerization time, we can increase the molecular weight. Now, by changing the UV radiation energy, we can also change the functionality of the polymer. So using those two parameters that we can regulate very precisely, we can actually design a polymer that is that have the right molecular weight and the right positive charge to suit any microalgae that we have. Now we use NMR. Yesterday in the afternoon, we visited the lab here, same or similar NMR instrument to take the measurement and verify that we can achieve 99% polymerization efficiency, and the polymer is exactly what we would like to have. Then we compare the performance of our polymer with other polymer that are commercially available. Now, of course, our polymer is specially designed and tuned for microalgae harvesting, and you can see that our polymer is the on the right-hand side is the one that have circular circle. Our polymer outperform all other commercially available polymer because they wasn't designed for microalgae harvesting. So either they have very low harvesting efficiency, as you can see on the top graph, or they have similar harvesting efficiency, but they require a much higher dosage compared to our polymer, as you can see at the bottom. Now, we have tested a number of different microalgae species, not the two, but that for the sake of illustration, I only present two polymer here to you. So we have that great polymer that we can tune specifically for any given microalgae. But that is not the end of the story. Now, the polymer, even though we only need to use a tiny dose, it is in chemical, and chemical input is always a cost factor into the equation. So we need to lower it as much as possible. Now, remember I mentioned before, the mature microalgae solution is only 1 gram per liter or 1 kilogram per cubic meter. That is very low. So if we don't do anything, we need to add a lot of chemical to do the harvesting. What can we do? We can pre-concentrate the microalgae solution by a factor of, say, 5 times or 10 times. Then we can significantly lower the polymer demand for our process. Next slide, please. So that's what we have done next. We look at membrane filtration. in this case, we actually use a ceramic membrane because ceramic membrane is very durable. You can clean it, you can do all sort of things with it, and it will last. So we use the ceramic membrane to pre-concentrate the microalgae solution to a factor of 5 times, and then we can add the polymer for harvesting. Next slide, please. Now, we test our membrane with a number of different species, and not surprisingly, the result indicates that the pre-concentration process is species specific. So depending on the species, they might respond slightly differently, but they work very well, right? So we are talking about a high solid content application and therefore high fouling. That's the only issue we have to deal with. You can see here the flux, which is given on the red curve, decrease over the time because of the deposition of some of the microalgae on the membrane surface, and of course most of the microalgae is in the pre-concentrated solution. And together with that decreasing flux, we also see an increase in transmembrane pressure. That is pretty normal when we have to deal with a very extreme solid content. Next slide, please. That's not really an issue because we can effectively clean the membrane afterward. So in membrane operation, there are 2 different ways to clean it. One is called backwashing. So this is a very simple cleaning. After one filtration cycle, all we need to do is to reverse the flows and a tiny bit of clean water in the opposite direction. We can resurface the membrane and then put it back to another cycle. In industrial scale operation, it can be done automatically. So you operate the membrane for, say, 10 minutes, backwash, and then you operate it again. That cycle goes on and on and on. So we see that backwashing is very effective, as you can see on the video there. However, when we do repetitive backwashing, we start seeing some issue that we need to address. That is because we are dealing with biological cellular material, and some of the organic material from the microalgae will actually attach to the membrane surface and cannot be removed by simple backwashing. Next slide, please. So when we repeatedly backwash the membrane, we can see a thing of green on the membrane surface. And next slide, please. And if we do it over 10 times, we can see that there is a gradual flux decline. And that is because of the extracellular material from the microalgae cell that then attach to the membrane surface. And it is too sticky for us to simply remove by backwashing. We need to do chemical cleaning. Now, chemical cleaning would introduce a cost factor into our process, and we don't want that. So we then have to come up with a solution. And the solution is a self-cleansing membrane. So what we have done, next slide, please, is we go back to the drawing board, and we decided that we will then do thin film coating to coat semiconducting material over the membrane surface that can be responsive to sunlight, and therefore allow self-cleansing to take place. So again, very similar to the instrument that we visited yesterday in the afternoon. We have that high caliber instrument in my in my university as well. So we sputter zinc oxide over the membrane surface. The membrane is actually the size of my iPad, so the chamber we have is very similar to the instrument we visited yesterday. And we time the duration of sputtering, and that would give us the thickness of coating. So we coat it over the stainless steel substrate, and we also coat it over aluminum oxide ceramic membrane. And they both work very, very well. So let me show you some results from our coating process. And next slide, please. After the coating process, we carry on the filtration experiment as normal. And then after that, we basically take the membrane out, radiate the membrane with a simulated sun. So it's one sun in terms of simulation. And then we check the flux again. We check on the characteristic of the membrane again to confirm that we have achieved the self-cleansing effect. Next slide, please. Now, I mentioned to you before, we can control the thickness of the coating layer, and that's simply done by the sputtering time or the coating time. And in our case, we aim to achieve 200, let me just quickly look at it here, 200, 450, 750, and 1,000 nanometer in thickness. So remember, the unit is nanometer, it's actually very thin. So with that thickness, we don't actually change the porosity of the substrate ceramic membrane. It's almost the same. We verify that by a profilometer. So we basically do the same process, but instead of coating the membrane, we coat a glass slide, and then we do the thickness measurement. And the result here, let me see if this thing works. Oh, now can you come back one slide? Just come back one slide. I might have to. So if you look at the graph at the middle, you can see that we aim for 200 nanometer, we get 203 nanometer. We aim for 450, we have 447. That's close enough. The SEM image of the membrane surface is on the right-hand side, and you can see that when we do the coating, we have not actually changed the nature of the membrane porosity. On the far left, you will see the PR signal to confirm that we have a zinc oxide coating layer on the membrane surface. And at the bottom, you can see the band gap of our zinc oxide. And it's about 2.3 EV, which is right at the band gap that is ideal for trapping a photon from sunlight and then releasing it to trigger the production of the free radical hydroxyl. That will do the cell cleansing effect later on. Next slide, please. We characterized the membrane, and surprisingly, and it is somewhat unexpected, but it's good news, the membrane is more hydrophilic, meaning it likes water, it loves water more. And hydrophilic membrane means that the clean water flux is a little bit higher. And in fact, we see that in our flux profile on the left-hand side. You can see that the bottom set of data in red is the virgin uncoated membrane. And as we coat the membrane, we start seeing the flux increasing, the flux, in this case, is actually the transmembrane pressure. The transmembrane pressure, I take it back. The virgin membrane is actually the black set of data. Black set of data there. Sorry that the laser doesn't work, so I can't show it to you, but the black set of data is the virgin membrane. And as we do the zinc coating, because the membrane becomes more hydrophilic, the transmembrane pressure actually decreased slightly as we go from 200 to 450 to 750 nanometer. However, at 1,000 nanometer thickness, the transmembrane pressure is quite high. And that indicates that at 1,000 nanometer, we might overcoat the membrane and start blocking some of the pore of the membrane. So for this reason, later on, I will not show you data at the 1,000 nanometer thickness. Next slide, please. So we look at the coated membrane behavior with the filtration process. Everything now is expected. We get good reproducibility. We can carry on the filtration experiment as if we haven't actually coated the membrane, and we can do it repeatedly again and again. The difference is, now we have a self-cleansing membrane. So all we need to do is to radiate the membrane with sunlight or UV, if you have energy availability, then the membrane will clean by itself. Next slide, please. And that is showing here. On the right-hand side, you see the first graph. The first set of data is when we look at the uncoated membrane. The clean water flux is the first set of data, and then after fouling, you see that the flux decreased by more than 50%. And then you can take the membrane out, radiate with sunlight. You actually see some cleaning effect, even though we haven't got any of the zinc oxide at the membrane surface. There is some cleaning effect, and that is because sunlight by itself is actually quite good in disinfecting and also in detaching the material from the membrane surface. But the effect is nowhere near what we would like to have. Once we move slightly to the left-hand side, you can see at 200 nanometer, you see the impact of cell cleansing is quite clear. Most of the initial flux have been recovered after sunlight radiation. And when we move to 450 nanometer, you can see that we can recover 100% of the flux. So now we have a cell cleansing membrane, a very effective cell cleansing membrane. At 750 nanometer, we can also recover all of the flux, but at that point, we don't see the reason to increase the thickness to that high level. Now, if we look at the actual image of the membrane surface, you can see that after cell cleansing, we don't see any remnants of microalgae fragments on the membrane surface. The membrane is very clean. So we have very good cell cleansing effect. So cell cleansing and the ability to coat a catalytic surface to the membrane is another breakthrough that we have achieved. So put the two things together, we can now start looking at the journey of scaling up the process of producing large-scale microalgae and capture CO2. Next slide, please. So our vision from here forward is to be able to produce containerized modular CO2 capture unit based on microalgae. So the vision is if we have a lot of desert land, we can then build many of these containerized units, stack them together, bring it to the desert. The water can be recycled. In fact, I'm not showing you here, but we have done significant amount of work to look at water recycling as well, to make sure that we can recirculate all the water for microalgae production. The idea is to be able to produce microalgae at about 1 kilogram per liter. And next slide, please. We started the project with the concept of green genie. That's what we call our container. And the container have been, we have got the honor of receiving our federal environmental minister, Her Excellency Tanya Pilbersek. She came to UTS, to my university in 2023, visited the container and looked at our technology. Since then, last year, next slide please, we have now spin out the research. We put together a portfolio of 5 patents, and now the 5 patents have been transferred to a spin-out company called L-Genie. So from Green Genie, we now have a company called L-Genie. And L-Genie is actually calling for investment at the moment and continue with the journey of scaling up. So you can check out the company website. I'm continue to be part of the scientific team, but the company now have a CEO and they have a structure to call for investment. The university is still the biggest shareholder of the company. Next slide, please. So I don't want to quickly recap to hopefully show you the potential of microalgae. That is, I think, highly suitable for Australia and perhaps also very suitable here in Saudi Arabia, where you have a lot of sunlight and a lot of land as well. Next slide, please. So I know my time is up. I would like to thank my funding agency and some encouragement that my team and I have got along the way. And next slide, please. And most importantly, I would like to acknowledge the many people whom work I have got the opportunity to present today. So some of my students, postdoc, and also my collaborator, starting from the far left, Professor Peter Raff, my colleagues from the Faculty of Science, and then 2 other colleagues who have contributed to the work that our team present to you today. Thank you very much.
Thank you so much, Professor Long, for this insightful contribution on bio-based carbon capture and its role in climate mitigation. Our next speaker is Professor Prasenjit Mundal. He's the head of the Department of Chemical Engineering at the Indian Institute of Technology, Roorkee in India. His presentation is titled Sustainable Transformation of Waste Packaging Plastic to Valuable Products, a Circular Economy Approach. Professor Mundal will review advanced routes for recycling waste packaging plastics into high-value products, emphasizing process technology, life cycle perspective, and the economic and environmental benefits of a circular economy. Professor Mundal, the stage is yours.
Assalamu alaikum, namaste, and very good morning to everyone. It is my immense pleasure to be here in presence in front of this august audience and to speak on this topic in this international conference. So the topic is sustainable transformation of packaging plastics to value-added products or valuable products, a circular economy approach. So as you know, with the economic development and population growth, the waste generation across the globe is increasing day by day, and the nature of the solid waste, if we see the composition, it is changing day by day. And as per current scenario, the waste plastics is a significant part of municipal solid waste. Not only in urban area, if we go for the rural area also, significant amount of plastics are produced. And these plastics, it has unique properties, that is lightweight, its strength, etc. So government is trying to ban the plastic use because of its negative impact on the environment and sustainability, but most of the government are being failed. In our India also, government is failed to ban the plastics. So what is the solution? We need to find a way that will recycle or manage the plastics nicely so that microplastic pollution will also be reduced. And in this case, if we want to ensure the sustainability, then environmental sustainability is essential. So there are two aspects. If we need a solution for waste plastics, the question comes whether this process is sustainable. And next question comes, who will invest money to process the wastes? Nobody will be ready. No industry will be ready until there is any regulatory obligation. So that is why circular economy aspect is coming, that we have to find out a solution, we have to find out a route through which we can add some value to these wastes. So that is the circular economy approach. So in this talk, we'll be trying to understand the problem, the generation of waste plastics, then particularly the packaging plastics, which is very unique. I'll show you some examples of how these are very unique with respect to others. And then what can be the possible solutions and what will be the most suitable or sustainable solution. And then how the monetary benefits can be achieved. So that is the topic of the discussion, and the contents are like this: the generation of waste plastics, and then what are the technologies, and at last we will see at IIT Roorkee what we are doing on this. So this is the global plastic use and projections. If we take the baseline of previous slide. So if we take this baseline, 2019, so we see that 2060 prediction is there, So plastic usage will be increased, and waste plastic generation will also be increased, and mismanaged plastics or plastic leakage will also be increased if we do not take proper action today. If we take action today, you see 2060, there is a good possibility of reduction of leakage of plastics, and that is the mismanaged plastics. So that is our objective to all of us across the globe, to reduce the usage of plastics, and if not possible, to recycle it, and then so that we can achieve our goal by 2060 without leakage of plastics or minimal leakage of plastic. Next. So now if we see the status across the globe, so Canada, US, China, India, OECD, EU, Latin America, Asia, Middle East, so everywhere you see that mismanaged litter is there. In India, 43%, and also Middle East, you see 39%. So this percentage of waste plastics are not managed properly. Next. So as I told you that plastics may be of different types. So 7 types of plastics they have classified, and some examples I have given. And you see the right side is showing some plastics which are basically packaging plastics. So these plastics are made of PP, polyethylene, HDP, LDP, etc. And those plastics floats and clogs the drain line, and flood-like situation arises in the urban structure. And in villages also, you see the ponds are covered with the plastics. Okay. The solid waste heaps are there, the animals are there, they are coming for food, but they are ingesting this one is plastics. So these plastics are also being deteriorated with time and creating microplastics and coming to the water, and also since the density is less, it is coming to the river and river to ocean, and microplastic issue is generating. So this is the situation. It impacts on our health, on our soil quality, etc. Next. So now we see that circular economy, as by definition of circular economy, our process will be reducing the utilization of fresh material, and will be using the waste materials in the process. So that is the objective, and to achieve this, we need to take action in every steps, in the project design, in the processing, in the utilization and recycling. Every steps we need to take action. I'll give you some example which we have done at our IIT Roorkee, so it will be very clear how the things can help us to achieve circular economic concept. Next. So these are the advantages of circular economy. That is your that reduces greenhouse gas emissions, job creations, okay, resource utilization will be reduced, and ultimately main focus will be the recycling. So next. So recycling, if we think, then what are the different processes that people have used? There are primary, secondary, tertiary, and quaternary processes, but out of these, secondary and tertiary processes are mostly used. The secondary process, next. In the secondary process, what do we do? The plastics is collected after shredding, then it is melted and mixed, and then some molds, and then we get different products. So this is the secondary process, and in the next, in the tertiary process, we apply heat, and basically it is a pyrolysis process. So heat, the plastic is converted to vapor, and then that is condensed. After condensation, we get liquid, we get also uncondensable gases, and we get char materials. So these 3 different materials will be having their own different values, some positive, some negative as well. So we have to understand the quality of those products, the process parameters which will give different content of the solid, gas, and liquid products. So next. Next. So that is your, if we think about our sustainability aspect, so our sustainability is under threat today, So our process should be environmentally benign, economically feasible, and socially equitable. So that is the concept we need. And for this, that UN has decided SDG, Sustainable Development Goal. So environment sustainability is one of the important parameter for ensuring sustainability. So we will be discussing on that. Next. So for environmental sustainability, we have to do some life cycle analysis study. So what are the different options we have? What are the environmental impact? If we do some LC analysis, through that we will be able to understand, and we will screen the processes. We can screen the products. Okay, so that way we can do that. So in this case, we do, next slide, previous slide. So in that case, there are different approaches to cradle to grave, cradle to gate, and gate to gate, and cradle to cradle. So that means that is our system boundary, which one we are considering. We may consider, say, some material is coming to my industry is creating some pollution and generating some product. So in that case, how much environmental damage we are creating. So that is gate to gate. A cradle to gate, so it is coming from the source raw material to the final product. Again, the raw material to, again, after recycling, which is coming after the end of life. So that different concepts have been implemented, and that will depend upon the situation. In our practical case, which one is more suitable, we will be selecting that one. Next. Okay, so now we will be seeing that we have done some studies at IIT Roorkee on that direction, and those are waste to wealth conversion from waste plastics through secondary recycling. So we'll be discussing our production of deployable products to reduce the usage of cement in concrete and reduce greenhouse gas emission. Then life cycle assessment of cement and cementless bricks and other products production. And then waste to wealth conversion from waste plastics through tertiary recycling, that is pyrolysis process. Then pyrolysis of waste plastics, both catalytic and non-catalytic route. And then life cycle analysis of secondary and tertiary process. Next. So we have developed one technology here for the usage of these waste plastics, particularly the packaging plastics. Then we have developed a technology and patented it, and then converted different deployable products, like paper block, and then trackway. And these products are very unique with respect to concrete products. If we see that cost is low, then your fire and heat resistant property you can achieve, lightweight, and it is not breakable, and fair resale value, anti-skid properties, and then eco-friendly. So these are the different positive properties we can get in these products. Next. So if we want to replace the concrete, then what are the possible options? The people have tried to melt the plastics and then use the cement, sand, etc., but with less amount of cement. That is one option. Another option is, we are going to that, we are not completely melting. So plastics will be used as a binder, not cement as a binder, but it will be mixed with some additives and heated. So one slurry will be formed, so that in that process we will be able to get the job done at lower temperature. So our heat requirement will be reduced and carbon dioxide gas emission will be reduced. So there are 4 options which we can develop. And before that, just what are the difference between these concrete and these plastics blocks? The concrete block, we know that we use cement and it helps for the binding and it takes curing time of, say, many days. But in case of plastics, next, it is a composite formations, so few minutes is enough to get strength. So this is the unique nature of this. Next. And this is our process, what we have done. After shredding, we have used 2 processes. One, after shredding, we have made agglomeration, and another case we have made beads. If we go for agglomeration production, our rate of productions will be less. But if we go for bead productions, then our rate of productions will be less. The machine will be having higher capacity. So, if we need in our campus, at this university or at IIT Roorkee to campus, if we want to manage the waste plastics, then we can have a unit here and that can be processed. So that is the concept, and we are getting success, and we are going to provide some units to Indian Army for that application. And another is your bigger scale for municipality. So in that case, we will be producing the beads from the plastics, and then other process are same. The melting and then not melting, mixing with the binding, and then it is heated and converted to slurry, and then the molds. This is our first product we made, the bricks and tiles. Next. Later, these are the properties we have got. So that is the less than 1 gram per centimeter cube density was there. We have enhanced it to 1.4 gram per cc. So now the material is not floating. So microplastic productions will be less. And then the water contaminations with the plastics will be less. Another, we have got sufficient mechanical strength, and abrasion properties is superior than many other materials, and hardness is also enough for deployable applications. Next. These are some our products, so tiles, and then Army Trackway and Speed Breaker. Presently, we are working on the Speed Breaker, and Army Trackway is developed and being supplied to Indian Army. 1 kilometer trackway we are providing now. So now the circular economy aspect is playing a role here. You see, our first product was paver block. That was not economically feasible. So that was not economically feasible. So we changed the design, made it economically feasible, and this trackway product is another product. So we have targeted to produce other product that is highly profitable. So now anybody will be wanting to produce this type of plastics through this route. Okay, next. So these are our, we have demonstrated the products at IIT Roorkee for more than 2 years. And you see, as I told you, the comparison of our product at the right side and the conventional concrete-based product, cement-based concrete. So no chance of breakage of the product. The aesthetic looks is very nice. So that way, this can get some attraction from the consumers. Next. Next. So this is the actual figure, the trackway we have provided to Indian Army for field trial. Next. Next slide. So this is a comparison of this trackway. So as on today, the conventional ATW track, so Indian Army is using, this track is used for the movement of the vehicles in desert area or say soily area, so that this trackway is spread, and on that the vehicles move. So that is the objective. So now this is our conventional is your aluminum based trackway. So in between, another trackway has come by other players. So that is your Altia trackway, and this is our invention. So if we compare these 3 competitors in market today, so our product is having very, very lighter with respect to others. So 1/2 of the conventional one, and our cost is 1/3 of the conventional one. But still, with this price, we can achieve huge amount of profit. So there is a good scope of this, and we expect to get very big assignment soon after 1 kilometer supply of the product to the Indian Army. So next. So same thing I have shown the next. So now, if we think about the sustainability aspect, so then LCA is needed. So LCA is needed. So the LCA, we have, as I told you, 5 cases. One is your conventional concrete paver block. Another is your plastic used as filler material with other cementous materials, that is PFPB, and then plastic used as binder with sand. So that is PBPB, sand, and plastic used as binder with other materials, that is PBPB additives. So additives is other materials, that is also waste material generated from other process. So this process we are following, and if we see the functional unit is 1 meter square land area coverage, so then and cradle to gate, and 2000 CML 2001 methods using the Gavi software. Next. The results are like this. Please, next. So this is our system boundary. Next, for the 4 processes. Next. Next slide. Yeah. So these are 4 system boundary, different processes, energy and mass utilization, and next. So life cycle analysis. If we see that the yellow color, all the parameters, environmental parameters are indexes are having lower value. So we claim that this process is able to reduce the environmental emission, and that will help to achieve the sustainability. Next. And this is another, we have developed one technology for wastewater treatment. So where we electrocoagulation based wastewater treatment for the removal of fluoride, arsenic, heavy metals from the water, and the material which is generated, that we are using for the plastics generation. So that is another uniqueness of the process. Next. And this tertiary processing for pyrolysis, we have initially investigated, we have developed a technology again for the lab scale production, so 1 kg per hour capacity. Okay, so that this is your waste plastics to oil production, and we have used different catalysts. So some of those investigations and results are shown here. Next. And again we have done some LCA, that is your catalytic pyrolysis using HNP based catalyst, and that is secondary recycling. Okay, so the secondary and tertiary recycling we are comparing now. So these are the system boundary for these 2 processes. And next slide. Yeah, so these are, you see, the environmental impact. So secondary processes is having very less environmental impact with respect to tertiary processes. So we recommended the use of the secondary processes for the recycling of the packaging plastics in place of tertiary treatment, because I have experienced when I was experimenting with the pyrolysis process, it was very difficult to, to prevent the gas leak and the smell which was coming out of the process. But when we are going for the secondary process, there is no problem with it. So that way we can achieve the sustainability goal. Next. So we can now conclude that the secondary recycling is more environmentally friendly than the tertiary recycling, and it achieves the circular economy concept. It also achieves the sustainability as well. So LCA helps to decide appropriate process to achieve sustainability. Next. So these are our sponsor. We are thankful to IIT Roorkee, IIT Kanpur, Indian Army, Department of Science and Technology, Ministry of Education, and also Ministry of Housing and Urban Development, Government of India. And we have got some award, and we are also thankful to HIOSI India and SCRD and Green Chemistry. Next. So thank you very much for your patience.
Thank you, Professor Mendel, for that comprehensive overview of how waste plastic can be transformed into valuable resources within a circular economy framework. Our final speaker in this plenary session is Dr. Diavit Vu, Professor and Deputy Director at the Institute of Environmental Science at Nguyen Tat University in Vietnam. His talk is titled Sustainable HT2 Production and CO2 Mitigation via Catalytic Reforming Processing on Ni and Co-based catalysts. Dr. Vu will discuss how advanced catalytic reforming process can enable low carbon hydrogen production and CO2 mitigation, reviewing catalyst design, reaction pathways, and prospects for cleaner fuel and chemical production. Dr. Vu, the stage is yours.
Good morning, everyone, and welcome to my presentation. Firstly, I would like to appreciate the organizing committee for giving me a chance to be here today. I thank the team also support me until the last minute to fix my name on the flight ticket so I can board the flight. I'm really excited to be here. So the topic of my talk is sustainable hydrogen production and CO2 mitigation via catalytic reforming processes on nickel and cobalt-based catalysts. So basically, in my talk, I will emphasize 3 main points about what I do, what I can do, and the most important thing, what I cannot do. So if you are interested in my work, you may contact me to collaborate and solve the current challenges in my area, which I cannot do at the moment. So let's move on to the next slide. I graduated from University of New South Wales, and then I go around several places to work. Finally, I met my wife, and she scared me like, if I don't go home, I might be kicked out of home. So I decided to return to Vietnam and work from 2019. Let's move on to see my research interest. So my research interest, so I work on mainly 5 topics. The first one is hydrogen production and utilization, in which I use thermochemical processes to produce hydrogen, and then to utilize it, hydrogen to form useful chemical, which I will talk today. The other topic will be I research on the converting of waste biomass to useful fuels, biofuel, and utilize all the side products of the biomass conversion like biochar to form absorbent used in wastewater treatment. I also work in photocatalysis, like you see the prolonged also use photolysis attached to the membrane for the treatment. So in here we not go more on the environmental treatment, but focus on hydrogen production from the photocatalysis processes. And the last topic is the recycle of waste plastic to form monomer and reuse it. So let's move on to the main talk today. So as we know, fossil fuel is the main energy which contribute to 80% of world energy consumption. However, if we use fossil fuel, it will release a large amount of CO2 emission, causing global warming. So across the world, people focus on looking for an alternative energy to somehow, like go say, cleaner than fossil fuel to partially replace it or diversify the energy sources. Among the renewable energy, there's a rising interest in hydrogen energy because it can use in a wide range of applications. It can be used as a standalone fuel, in fuel cell, in hydrogen car, or can be used in the petrochemical processes to form useful chemicals. If we look at the chart, say if we have a syngas, a mixture of hydrogen and CO, this mixture can be formed from the reforming processes. So they can use it in future jobs to form the synthetic fuel, can use as gasoline or jet fuel, or we can separate out hydrogen from the syngas, and from there we can form ammonia. We can be further uses in fertilizer or ethanol and other important chemicals. As we know, there is shipping of the energy types going toward the gaseous fuel, particularly hydrogen energy. If we assess the corpus and use the keyword hydrogen, we can form the type picture with the keyword hydrogen. You can see hydrogen energy is an interesting topic, and people are working on it, ranging from nanomaterial to synthesize, forming hydrogen to use hydrogen. Also, other topics related to the production, the separation, uses of hydrogen industry. Also, fuel cell, for example, it has attract a an increasing number of researchers in this field. For producing hydrogen, they can use thermochemical processes, which I will focus today, while other people they can use a biological method, photocatalysis or photoelectrocatalysis. So please, we look at the thermochemical process now. So in industry, there are three main approach which can be used for hydrogen. Firstly, the partial oxidation is the reaction of the natural gas and oxygen to form CO hydrogen. This process is very exothermic. Why they can do other approach like the steam reforming, in which they will provide steam from water to react with natural gas to form syngas. This process is endothermic. So they can combine both partial oxidation and steam reforming to utilize heat from the partial oxidation to supply to the steam reforming. They call autothermal processes, the last one. However, the three current approach using industry encounter the problem of a large amount of CO2 emission and it's the energy intensive processes. So there's a shift going to the radioforming approach. So what is radioforming? Actually, the reaction between hydrocarbon, for example, methane with CO2, we can obtain from the industry, like from cement industry. With that, we can form CO and hydrogen. With this approach, we not only reduce the emission of two types of greenhouse gases, methane and CO2, but also form an ideal hydrogen CO mixture with the desired hydrogen CO ratio for the downstream processing. We can have a look at the methane reforming. There is multiple reactions occur simultaneously during the process. Apart from the methane reforming, there is the reaction in which the methane will be decomposed to form carbon and hydrogen, and also the Boudreau reaction. It can form carbon. So there are two main undesired side reactions. It can form carbon, and with the main factor causing the catalytic deactivation, it can hinder the potential for industrial application of the radioforming processes. So now I go on to give an example in our work case study to perform the PR promoted cobalt on mesoborate calyx, mesoborate alumina calyx. Actually, we synthesize the material using the hydrothermal approach, using P123 at the template, and then disperse the aluminum salt from organic, and then conducting the hydrothermal approach to form the mesoborate alumina, while the cobalt and PR can disperse on the surface calyx by using impregnation approach. Basing on the result, you see the calyx is very stable, and we have obtained high performance with the PR promoter. If we look at the XPS result, see here, let's say that we visit the central lab, you can see the XPS equipment, but in our country, we don't have it, so we need to collaborate with overseas to obtain this type of measurement. So for XPS, we can detect the oxygen vacancy on the calyx. You can see that with the adding of PR, promoter can form oxygen vacancy on the promoter or the calyx. Therefore, it can contribute to enhance the CO2 absorption, to take out the CO2, oxygen from the CO2, and hence this type of oxygen can react with the surface soft carbon to form CO, and can push the activity of methane reforming reaction. This is another example. We can use the boron promoter to reduce the carbon deposition. So we add in boron on the boron and cobalt on the mesoborate alumina using hydrothermal approach and incipient impregnation technique. By doing characterization, you can see on the surface calyx they have a filamental carbon cover the surface, but if we use with the ball of the motor, the amount of carbon did drop. We don't see the presence of filamental carbon on the SEM image. We can see the reaction of catalyst is quite efficient. It can bring down the carbon oxide to carbon metallic. By look at the performance of catalyst, you can see if we add in 0.3% boron, it not only hinder carbon deposition, but also enhance the catalytic activity up to 90% of methane conversion, and can yield a high amount of hydrogen and CO yield. In addition, the hydrogen-CO ratio, we can obtain the value less than 1, which is an ideal mixture which can be used directly in downstream processing of future job to form the olefin-containing compounds. Here the result you can see when we look at the carbon on catalyst surface, we have two types of carbon based on the TPO measurement and even the Raman. That we have amorphous and graphite. The type of carbon can cause catalytic degradation, but when we add in boron, the amount of carbon has been reduced a lot. Again, we perform XPS and we see we can confirm the oxygen we can see on the surface catalyst. Therefore, we can propose a mechanism for the methane methane reforming on the bottom of the motor catalyst. See, firstly, the methane will absorb dissociatively to form C carbon on the surface and hydrogen species. Also, the oxygen we can see will take out the oxygen from CO2, and then this surface oxygen will react with C on the surface catalyst to form Cl. While the hydrogen can absorb hydrogen can react with each other to form hydrogen molecule. We also perform the kinetic modeling for the cobalt catalyst on alumina using different model from literature, basing on whether the mechanism whether the methane will absorb molecularly or dissociatively, and they absorb on one side or two different active sites. So we found the model number 5. The methane and CO2 absorb dissociatively on one active site is the best model. Capture capture both experimental data, and also satisfy the thermodynamic criteria, and therefore we can go to the mechanism of this type of methane reforming reaction, in which the methane and CO2 absorb in the same active site, and the form CH species will react with the surface oxygen to form CO hydrogen. Okay. So now we move on to other type of reforming processes. So firstly, what is the reason we do other type of reforming processes? Firstly, for the methane bioreforming, we want to control the composition of syngas to bring it to the ratio of 2:1, 2 hydrogen and 1 CO. While the reforming of biomass derived feedstock, for example, the ethanol, acetic acid, and ethylene glycol, we want to diversify the source of feedstock for the reforming processes to produce hydrogen, and also the type of feedstock have a high content of hydrogen molecule. So firstly, we look at the methane bioreforming. This reaction, actually, we add in water steam into the reforming process. So with the adding water into the reforming, we can manipulate hydrogen CO ratio to 2, and we can see with the desired temperature and remote loading, we can bring the hydrogen and CO ratio to exactly 2, which is a good condition for the future job synthesis. By look at the carbon on the surface, we can see there's no presence of both type carbon, amorphous amorphous carbon as well as recycled carbon on the surface of calyx. What's the reason we can hinder the formation of carbon? Say when we in the boron can occupy the first surface layer of nickel, and hence there will be no space for carbon diffuse to the first surface layer of the nickel calyx. Therefore, it hinders carbon forming the island and rolling. You see? Yeah. Now we look at the other type of reinforcement, ethanol reinforcement. This type of reaction, if we look at the relationship between ethanol conversion and the methane formation, the yield, we can see the opposite trend. If we have a lot of ethanol conversion, we have less amount of methane yield. So we can propose, we can see the overall process has two steps. The ethanol decomposes to form methane, and then methane will further reacted to form CO hydrogen. However, the detailed mechanism could be more complex and would require a more analytical analysis as well as analytical instrument to institute detecting the forming of the other byproducts. Therefore, and then we can propose the detailed mechanism, which is the current challenges in this area, and we couldn't solve it yet. If we look at the surface carbon, the surface calyx, the calyx is entirely covered by carbon. Why it happened like that? Because in the ethanol we have two carbon. So under the high temperature, it can easily form carbon and covering the entire surface of the active site. It can lead to the calyx deactivation with time on stream. So we think about a way how to bring down the carbon deposition. And we are the first group in the world to propose this approach. We introduce a small amount of oxygen into the ethanol reinforcement, call it oxidative reinforcement of ethanol. So with a small amount of oxygen going into the reaction, we can successfully bring out the activity up to 100% and also bring down and reduce carbon deposition from things like from 40 something to 30%. It can bring down carbon deposition, hinder, because oxygen will play a role. It can oxidize the carbon from the calyx surface to maintain the surface calyx is free from carbon, and hence it can improve the stability with time on stream. Recently, we perform also the converting of acetic acid by dry reforming. While other people focus on steam reforming, we propose the process of using dry reforming approach, which is the first time performed by our group and in the world. So with this approach, we can ensure the forming of sustainable hydrogen, green hydrogen, and minimize oxygen deposition. Okay, so time limited, so I will go quickly skip some slide. I just confirm, it's meaning we just confirm the activity of acetic acid reinforcement. Okay, the problem with this process is the calyx seems to be not stable yet. So we think about future work to add in some promoter or modify the process to enhance the calyx stability. See the same behavior for the yield hydrogen and CO. It's not stable with time on stream yet. The calyx is formed by a lot of carbon on the surface, but we can increase the temperature due to the presence of reverse polar reaction. It can bring down the carbon deposition on calyx, and or in the serial motor, it can also help to reduce carbon deposition. Same here, we perform the ethylene glycol. I can confirm this is a process to form hydrogen CO because ethylene glycol is one main component in biofuel. So we think if we confirm ethanol glycol reforming is feasible, so there will be a chance to convert bio oil obtained from biolysis process to hydrogen hydrogen. So far, we have confirmed the feasible for forming hydrogen from different types of biomass, derived feedstock. However, to study the mechanism and modeling, it could be required further study. Okay, now I just saw some picture about my research group in Malaysia, in Vietnam, and also where I'm from. I'm from Vietnam, not far away from Saudi Arabia. Unfortunately, there are no direct flight yet, but I think in the next 1-2 years, there will be direct flight from Saudi Arabia to Vietnam. So some picture of my city, Saigon. It's an entertaining city. Next one. I mean, go to next slide. So here we have many interesting points from historical building, forest, beaches, nice. So if you have a chance, please visit and give me a text. If you are there, we can meet over in Ho Chi Minh City. Okay, this is the end of my presentation. Thank you for your attention. Thank you.
Thank you so much, Dr. Wu, for shedding light on sustainable hydrogen production and its role in reducing emissions. Before we end this, let me just say, after this recycling session, I guess if anyone throws like a bottle in the wrong bin, then they should be punished, and we have all the local and international experts here who will chase you and correct that, mistake. Ladies and gentlemen, once again, please join me in thanking our distinguished speakers for an excellent session. Now, instead of letting all these great ideas leave away, we are moving to the panel discussion titled Reinventing Waste from Disposal to Circular Innovation in Cities and Industries. This panel will be moderated by Professor Nasser Sayed Awad. Our panelists are Professor Long Di Nim, Professor Wu, and Professor Ibrahim Hussein. I kindly invite you to Professor Nasser and our honorary panelists to join us on stage and begin the discussion.
Hello and welcome. We are delighted to meet you on the second day of the conference on sustainable solutions in energy and the environment. This session will feature 3 speakers. You are listening to him before in the field of circular economy innovations, and our discussion will be under the theme of reinventing waste from disposal to circular innovation in cities and industry. Shall cover and focus on 5 topics: waste management in Saudi Arabia, waste reduction, circular economy, technological innovation in waste recovery and recycling, government policy for waste handling and management, impact of waste on the environment and human health. Shall be starting with Professor Long Negam. You are listening to him in interesting topics before. Director of the Center for Technology in Waste and Wastewater, University of Technology, Sydney, Australia. The first question shall be with the Professor Long. Professor Long, Vision 2030 places strong emphasis on sustainability and circular economy principle. How does Saudi Arabia waste management strategy, particularly its high-level waste categories, align with or differ from global practice? Please.
Thank you very much. So I've been here for 2 days, but I feel I learned a lot, and I try to learn a lot more as well. And I try to answer the question from my perspective and also bring in some of the experience from Australia. I might not be able to offer a full answer because still learning about Saudi Arabia. But I did go through the Vision 2030 that the kingdom have published recently. And I got to say that at high level, the strategy that have stated in the vision is broadly consistent with international best practice. So there's now clear classification of waste, going from hazardous waste, industrial waste, construction waste to commercial waste, and then municipal solid waste. So there's a very standardization process happening. The kingdom have embraced the principle of circular economy very clearly. Yes. And that, I think, another evidence of consistency with the best practice internationally. And of course, the Vision 2030 also called for the establishment of the National Center for Waste Management. So that is a giant step forward to address, and not to address the problem of waste, but turn it around and transform waste into economic activity. Of course, there are some subtle differences, and I think this is where I can perhaps contribute a little bit more, because we all have a localized context. There are, as I mentioned earlier on, quite a few similarities between Saudi Arabia and Australia. Dry climate, very dry climate, relatively large landmass with small population. But it's also different in the way that the government is operating as well. So in Australia, it's more decentralized. So historically, because of our constitution, environmental management is actually done at the state level. The federal government in Australia do not have the capability, and under the constitution, the constitutional power to manage environmental matter in Australia. However, in Saudi Arabia, I can see that it's quite the opposite. It is more of a centralized approach. Now, the two extremes work for Australia and work for Saudi Arabia, so sometimes differences are good. Yes. The other thing that I think very worth noting is the very fast development in technical guideline in how to deal with waste and classification and technology here in Saudi Arabia. That perhaps a subtle difference with the rest of the world as well. I think one thing that set Saudi Arabia quite apart is a very strong focus on economic transformation. So not looking at waste as a problem, but looking at waste as economic diversification. Because we all know the kingdom in the past have historically relied on oil as the main revenue. Vision 2030 called for diversification and non-oil revenues. And waste is actually one of them. So I think that speak volume to the recent initiative, the very fast-moving effort that the kingdom have got, and the focus on economically transformation opportunities would allow the kingdom to be a good example of how waste can be transformed into resources and turned into a new economic opportunity.
Thank you, Prof, for your concise and concentrated answer. Shall we move now for Professor Daya, and already listened to him about his interesting lecture about syngas. Professor Daya, Professor and Deputy Director, Institute of Environmental Science, Nighan Tat University, Vietnam. Starting for the first question for Professor Daya. What innovative waste collection technology are used in Saudi Arabia city to combat urbanizations and the climate change? Please, Prof.
Thank you for the question. Actually, I also are doing a research about Saudi Arabia, about a smart city here to be able to give some reply here. Actually, when we look at the word smart, something like advanced, it could be, we refer to something like digital advanced technology. For example, like Internet of Things or AI can help in the waste collection in a smart city in Saudi Arabia. Why I know? Actually, it's, I think it's some certain states like Jeddah or Riyadh, they have developed some of the smart bin to collecting the waste. They can employ Internet of Things to monitor with time on stream about the level of the waste inside the bin, and also they can use AI-assisted approach to maximize, optimize the collection time, the route and times, considering the situation of weather as well as the traffic. So with that way, they can minimize the number of transportation, the collection from the household to the central waste management, minimize the emission of CO2 and the number of the truck trip to collecting the waste. Those are some of the approach we can be used in a smart city to collect the waste.
Thank you, Prof. Now, shall we transfer our third panelist with us today, Professor Ibrahim Hussein, Professor of Nanotechnology, Department of Physics, College of Science, King Khalid University, Saudi Arabia. And shall move to the first question for Professor Ibrahim. How does Saudi Arabia waste categorizations align with the Vision 2030, and what is the role of the Saudi Green Initiatives? Please, Prof.
Thank you, Prof. Nasser, for this question and nice question. We would like to speak about Saudi Arabia Vision 2030. And according to this vision, we have a lot of rules and laws inside Saudi Arabia about national waste management strategy and national waste management rules inside Saudi Arabia. We have a lot of category in pollutant and waste inside Saudi Arabia about construction, industrial, hazard, and also medical waste. And according to this vision, Saudi Arabia apply new rules and apply also a huge funding for changing this waste to a useful product. This useful product is important for us to be recycling again inside our society, and also it will be decrease the landfill and also decreasing the waste. Saudi Arabia also supporting this transformation of waste and recycle to be another kind of circular economy, not by direct investment in the economy, but also something about backdoor investment. This backdoor investment using recycling of the waste will support our economy, but not also support our economy, but will open new companies, new industrial, create new job inside Saudi Arabia. Also alignment with the 2030 vision, Saudi Green Initiative Program, SGI, one of the alignment with Saudi Vision 2030, and one is important goal of this Saudi SGI is 94% of the landfill of the waste inside Saudi Arabia will be removed by 2035. This is one of the important goals. This is supported by public investment fund and also with a lot of company with huge funding to recycling our waste. Recycling our waste, one of the core pillar also for kingdom, climate and environmental sustainability, and this is a systematic waste management in Saudi Arabia. We are looking for small business also in Saudi Arabia about the waste company for supporting the younger to make such investment inside the waste, and also to start to make companies associated with a lot of supporting our younger and create new job by themselves, not waiting the job from the government. That is it.
Thank you, Professor Ibrahim, for your long answer, but very concise also. So I shall transfer now to another topics, very important topics about environmental degradations and public health. And the question for Professor Long, in the context of Saudi Arabia ecosystem, how does mismanaged waste contribute to environmental degradations and the public health risk? Please, Prof.
Thank you. I think the risk, mismanagement of waste material present a challenge to every country, not that in Saudi Arabia. But I want to perhaps answer the question by first provide some context, because I try to learn a little bit more about Saudi Arabia. So we have a relatively large country, very dry, so that's important. Rely a lot on groundwater as a source of water for drinking, for agricultural production, for many other things. The geological formation in Saudi Arabia also have a relatively highly permeate soil. And of course, dry climate, wind and the like, meaning that if we are not managing waste material well, we would have very fast and severe dispersion of waste material. And once the genie is out of the bottle, it's very hard to put everything back in. So basically that's the context. And the risk is real, and the risk is obviously groundwater contamination. If we don't manage we don't manage waste effectively. That health risk coming from the disease vectors that come with unmanaged organic waste. And of course, we also have another looming challenge, not that here in Saudi Arabia, but everywhere in the world. And Professor Mondial mentioned that plastic waste. Now, obviously, we have to live with some plastic. Plastic is part of our daily life. But managing plastic is also very important. Okay. So they are the health-associated risks. For Saudi Arabia, I think there's another lens that we need to look through. That is the depletion of nutrients that is actually very scarce here in Saudi Arabia. Now, we all know this place is very rich in oil, yes, but very poor in in fertile land. Mm-hmm. And food security is very, very important. Yes. So I think as a kingdom, it's very important to manage and retain as much nutrient as possible that is here on this land. Mm-hmm. And any organic material in the West need to be recirculated back to agricultural land as much as possible. And I think the statistic that I got is about 50% of municipal solid waste here is organic. That means there's huge opportunity for composting, anaerobic digestion, converting all the nutrient, all the organic material back into productive use. And I think that a risk, but it's also a good opportunity to convert that into economic activity.
Okay, thank you, Prof. Now shall be transfer Prof. Dia. Second question about what are Saudi Arabia circular economy implementations and outcome in key sectors, please.
Okay, thank you. Actually, the circular economy is a trend where many countries shifted or adapted to circular economy. So in Saudi Arabia, also did the same under the vision 2030. So the Saudi Arabia Green Initiative have adopted the circular economy with focus on the waste reduction, while encourage the reuse, repair, recycle of materials to minimize the waste and also to maximize the efficiency of resource. The kingdom has applied the circular economy in many key sectors, ranging from energy, manufacturing, waste treatment, and also mining. We can see the outcome clearly. The number of landfill waste has been reduced a lot, and we know the landfill waste is the main kind of waste which causing the contaminant to the water, the soil, and also causing the release of greenhouse gas. Additionally, we can look at the industry, for example, like Saudi Aramco. You can see the rate of reuse or recycle the material has been improved a lot. Yeah.
Thank you, Prof. Now shall be transferred to Professor Ibrahim, and he have good experience in this field. And I need to talk about emerging circular economy business models, okay, and the financing and the public investment rule in Saudi Arabia. Please.
Thank you, Prof. Thank you, Prof. I would like to speak about two important organizations inside Saudi Arabia, about صندوق الاستثمار السعودي BIF, the public investment funding, and this office are supporting the creating a new company in Saudi Arabia about SIRG. SIRC is about the Saudi Investment Recycling Company, one of the important company all over the world about the waste recycling, and also huge funds are applied to this company to control all the waste all over Saudi Arabia. Not only to this model about the creating of this new company, but also Saudi Arabia build a new strategy about monitoring two important things in our nation. The one is monitoring the health in every region in Saudi Arabia, and the second also monitoring about climate and environmental problems, and try to solving this data offline and online by remotely controlling the data analysis and also to make a decision. This is the three model in Saudi Arabia about the creating companies and also monitoring the health problem come from the waste and also monitoring the environmental problem. I think this is a very successful model that support the circular economy inside Saudi Arabia. Thank you, Prof.
Thank you, Prof. Welcome back again with Professor Long with very important questions about specific waste composition and operating condition, and how can be kingdom-based leverage emerging technology in waste management.
Thank you. When we look at technology, I think one thing very important is we need to see technology as an enabler and not a silver bullet itself. Yeah. Technology alone will not solve the problem for us. Yes. But it's important as an enabler. So I guess we need to then identify, so what are the key challenges that we and the rest of the world are facing? That would be organic fraction in municipal solid waste. That would be the issue of plastic. And that would also be the issue of commingled waste, meaning waste that have been mixed together because it is low value and therefore for fast and effective disposal, we tend to mix them together. They are the three key challenges that our innovative technology need to address. And therefore, the best way to leverage perhaps is to first look at how can we generate enough data and good data so that we can have effective decision making, and also go back to the population, to our family, and start having the conversation about separation at source. Because that is very important. If we can effectively separate the waste at source, facilitate recycling as much as possible, follow the waste management hierarchy, that would always be most effective. So, and we have digital transformation, we have AI, we have all sorts of tools that allow us to produce quality data that can fit into the decision-making process and to the public education process as well. Now then, when we look at how do we deploy technology, technology cannot be copy and paste from one country to another. So what's successful in Europe or in Asia, I bet that might not be copycat and be successful here in Saudi Arabia. We need to have our local context input into the technology, adapt it in the culture here, in the climate here, in the actual condition here. And that's very important. The list of technology are there. We have composting for nutrient recycling, anaerobic digestion if we want to convert organic material into biogas for energy generation. We can recover a lot of materials from waste like glass, like metal. And for any residual waste, there's another tool that is also very useful, that is to convert that into what we call synco in Australia. So basically, all the combustible material can be mixed with waste plastic. Waste plastic give us the binding capacity. And we basically have a machine that compresses the material into pellet. It looks like the water bottle that I have here. And we can use that to replace coal, to extend the lifetime of coal burning power station without releasing CO2 into the atmosphere. So that's how we can leverage the innovative technologies we have in our disposal. But technology, as I mentioned earlier on, alone is not a silver bullet. At the end of the day, we need financing, we need to have private investment, and we need to make sure that the technology can go hand in hand with entrepreneurs so that they have a home and they have the blood to live. I think if we can have data, we have good use of technology in a local context, and we have the right financing mechanism, then that would be the best way for us to leverage emerging and innovative technologies to convert waste into valuable materials, and waste management become an economic opportunity. Thank you.
Thank you, Prof. Now we have an important question for Professor Dia about how is digitalization's Internet of Things, AI, advancing Saudi Arabia waste management, and what is the role of National Center for Waste Management in Saudi Arabia?
Thank you, bro. Actually, digital technology play an important role in the waste management, particularly the Internet of Things and AI. In Saudi Arabia has adopted the digital technology in across the smart city and industry zones. For example, they can use Internet of Things sensor to online monitor the waste release. Can use AI to optimize the collection route, and also the AI sorting to separate out the collected waste. We can see clearly now there's many established way to energy plants in the country, in Jeddah and Riyadh. So by using digital technology, we can collect the waste and provide, I can say, the cleaner waste into the waste to energy plant and hence it can generate clean energy to reuse in industry.
Thank you, Prof. Now with the final questions with Professor Ibrahim. Professor Ibrahim, cutting edge and pilot scale technology used for recycle waste streams, for example, plastic, organic waste and fines. Please, I need short answer about the pilot technology in Saudi Arabia for high value recovery of hard to recycle waste.
Thank you, Prof. It is very nice question about pilot system to recycling our waste in Saudi Arabia. We have three categories of waste in Saudi Arabia we must remove from our landfill. The first one is about the plastic. As we know that Saudi Arabia producing million of bottles every day for our water drinking inside homes and everywhere. But in the same time, we are consuming this water and we need to recycle million of bottles every day. Especially in our Hajj time, this is a million of people for 15 days are staying in Saudi Arabia. How many bottles they are consumable in our Hajj time. So the plastic has a big problem and challenging in Saudi Arabia, and Saudi are putting a lot of rules to control the plastic harmful of our environmental. Our roads building are empty from plastic waste, especially PET. Let's start about converting the plastic PET to a foil. But also we can converting this plastic to nowadays about to make from PET some osmosis membrane with doping with graphene. So this is a new approach about using PET, propylene terephthalate to be as a membrane for wastewater treatment and also for desalination. Secondly, for organic waste, if you are using our organic waste every day, Saudi Arabia are make a lot of reactor to have a biomass and consumable this organic waste to be useful as a kind of energy in Saudi Arabia. But not only to this organic waste to be used as a biomass or a kind of energy, but converting of organic waste to use as a highly graded protein for animal feeding. Also, we can using from organic waste. For the third one about construction waste, this very fine product can be used and recyclable using geopolymer concrete using in our roadways, and also changing our constructions product to be useful in the landfill. If you know that KAUST, the university inside Jeddah, is taking a lot of huge funding about research and development inside the all kind of waste, and we hope also our university can join this strategy.
Thank you, Prof. And this is the last question for me, this special question for Professor Long. And this is the last question, inshallah. Professor Long, how can Saudi Arabia combine global-based practices, local environmental realities, and technological innovations to build an integrated system, long-term waste management system aligned with the Vision 2030? Please.
Thank you. I guess that the system that every single country in the globe is striking for. How can we take best practice internationally, take the best available technology, and achieve sustainability in waste management in the long term? Okay. Every single country on earth would try to hit that target. Okay. How do we do it in our context here in Saudi Arabia? When I went through the Vision 2030, I could see clearly that we're on the right track. The kingdom is on the right track. There's a clear vision to circular economy. With us, I should also say a clear focus on industrial ecology, meaning that waste in one process is actually the raw input to another process. That's the concept of industrial ecology. This clear action as well, the establishment of the National Center for Waste Management, and there are a number of targets that the members of the panel have already mentioned. Those targets are clearly stated in the National Transformation Program. So the precursor is already there. I think we just need two more things.
Yes.
One is the human capacity, and to make sure that we are fully aware of all the innovative technologies that are there that can be mobilized here in Saudi Arabia. And I think the question of human capacity is actually fitted very well to our current context. It's for the university. And for activity like this very conference that we are sitting here, we need to develop the internal human capacity within the kingdom to uptake and to localize and contextualize new technologies coming from elsewhere, and maybe develop technology from Saudi Arabia as well. Right? And this is actually a global issue, a global challenge. No one country should actually face it alone. Internationalization also means international collaboration. Best way to allow our buck to go as far as we can, most cost effective, is to have international collaboration. And again, this very event where we are talking to each other, sharing knowledge, is in itself the defined moment of international collaboration. So yes, again, I think we're very, very much on track. So with clear policy, clear target, the ability for upskill ourselves and enhance the human capacity, and the hospitality, the willingness to collaborate, the warm welcome that I have felt over the last 2 days. I'm sure that the target of having a sustainable waste management system is within the kingdom reach.
Okay, thank you, Prof. Professor Dia, if you need to add more any information, please, before go to Professor Ibrahim, you need to be end the session by make an initiative, go green, inshallah. Please.
Okay, again, I can see the kingdom has adapt to the updated technology to involve the private investment and apply across the country, ranging from the smart city to industrial zone, to minimize the waste and adapting to circular economy, which we believe that we can achieve the sustainable development.
Thank you, Prof. And by ending the session by Professor Ibrahim.
شكرا. شكرا لحضراتكم جميعا. أنا بحاول أتكلم باللغة العربية لآخر 4 دقائق من الجلسة الحوارية، وهي طبعا زي ما حضراتكم عارفين إن يوم 27 مارس 2021 كانت المبادرة الكبيرة من سمو ولي العهد الأمير محمد بن سلمان عن السعودية الخضراء، والتي تمتد وتنتهي في نهاية 2025. وإحنا من خلال المؤتمر ومن خلال الجلسة الحوارية ومن خلال الزملاء والأساتذة الأفاضل بنقدم أيضا مطلبنا لسمو ولي العهد لتبني رؤية جديدة خاصة بالسعودية الخضراء، ألا وهي Go to Green، التوجه نحو الأخضر، وهي لا تشمل أيضا انبعاث الكربون أو الصحراء الخضراء أو الحفاظ على البيئة، ولكن أيضا تمتد لكل نقطة داخل المملكة العربية السعودية، في المباني، في الجامعات، في المدارس، في بيوتنا، في الماركتينج، في المولز. وبالتالي في هذه الحالة احنا سوف نتحول جميعا كدولة خضراء. طبعا في الآخر أيضا أنا بحب شبابنا وبناتنا إن احنا نهتم ب3 حاجات أساسية في حياتنا ونحن في سن الشباب، ومحتاجين جهد وتعب كتير، ألا وهو الاهتمام ب3 حاجات: الاستثمار، البزنس الخاص، وايضا الماركتينج، التسويق. دول الثلاث حاجات اساسيه نتمنى لجميع شبابنا وبناتنا ان هم يبداوا فيهم من سن مبكر. شكرا لكم جميعا وتحياتي.
شكرا يا بروف ابراهيم، شكرا بروف لونج، بروف ضياء، بروف ابراهيم، and thank you for your attention. Thank you. شكرا.
While you're here, doctors, now I would like to open the floor for any questions from the audience regarding the topics that has been discussed. If there are any questions. Mike, صف الأول.
السلام عليكم. I'm Hakim Al-Nashiri from Asir Municipality. I'm sorry I can't talk by English about my question, but I need support from you. Make translate my question to Prof. Please. تكلمنا في الجلسات أو تعرفنا أنه فيه حلول مستدامة أو حلول ذكية في الاستدامة البيئية. اللي احنا نبغى نعرفه في أمانة منطقة عسير كيف نقدر نساهم في تحقيق الحلول الذكية في منطقة عسير خاصة في النطاقات البلدية فيها. شكرا.
The sustainability and how to consume the human sources and all capabilities here to solve the problem for management, for recycling the waste in these regions.
Thank you. So the question is about how do we maximize the human potential and human capacity to recycle material and to valorize waste in Saudi Arabia. I think our human capital is always the center point of everything we do. It's most important.
Yes.
And again, I go back to the role that the university and the education system have in order to upskill and also bring in a new perspective so that each and every family in Saudi Arabia will start sorting out the material, try to reduce the amount of material that they need to dispose. There's a lot of internal reuse and recycling that can happen at home. And then we can then look at using technology. Technology are readily available, so we have QR code, we have FTIR for scanning, so we can have a number of different bins for waste material that can be read automatically by the machine, that can be sorted out automatically as well. All of that actually need to have the human interface. So the question is actually vitally important because we have technology, but again, technology is only an enabler. We need to have someone who controls the technology and make use of the technology, and that is our human capital. So education and university training, I think is the direct answer and probably be the most effective investment in order to increase the recycling rate. The Vision 2030 calling for 95%. That is actually a very ambitious target, achievable though, if we can have enough investment in our education system and in the university research and training.
Okay, thank you, Professor.
Thank you.
هو طبعا بيتكلم على ان دي عمليه تكامليه وان الاستثمار يجب ان يتم وان في عمليه ميرج ما بين كل الجهات عشان نقدر نتعامل مع الويست لان دي قضيه كبيره جدا والاستثمار فيها مهم جدا 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 وطبعا هي بروسيس متكامله ممكن نتكلم فيها مع بعض احنا بعد ما نخلص ان شاء الله نديك موديل لحلول لبعض اوريدي المشاكل اللي كانت موجوده واحنا ازاي تعاملنا معاها اصلا من خلال مشاريع مدعومه من مدينه الملك عبد العزيز ويعني كانت في حلول لمياه مثلا مشكله مياه الابار في منطقه في منطقه عسير وازاي استخدمنا انويه التمر مثلا وان احنا وحاجه موجوده ولوكال وحلينا بيها المشكله وكانت بتعمل تخلص من كل العناصر السامه والثقيله بكفاءه عاليه جدا جدا وبحاجات اقتصاديه وموجوده ومشاريع اخرى تمت في المنطقه الشرقيه في الاحساء، لما خدنا قش الرز وفصلنا منه السيليكا واستخدمناه في انتاج الزيولايت، والزيولايت ده ماده سمارت، يعني من الحاجات الذكيه جدا اللي هي بتمد النبات بالفيرترايزر، وبتمده بالميه على فترات طويله، يعني عشان تستهلك كميه الميه المستهلكه والاسمده المستهلكه. فالموضوع اصلا بروجكت شغال خطير جدا، فاحنا ممكن نتكلم في الموضوع ده باستهابه بعد كده ان شاء الله.
Thank you very much. That was a really great answer and great questions from our guest. Actually, we would love to have more questions, but we could have it like privately after finishing this session. With that, this concludes our plenary and panel sessions. We extend our sincere gratitude to all the speakers and guests from this session and the previous one. For their valuable contributions, and to all the attendees for their engagement and presence in this morning. It is an honor to recognize and extend our deepest appreciation to our distinguished guests, and I would like to welcome them all to the stage for recognition. Please join me in giving them a warm round of applause. Samandal.
عشان الصورة.
We will resume, inshallah, our session like in 10 minutes from now. So please be here for the next session. الجلسة القادمة إن شاء الله بتبدأ بعد تقريبا 8 دقائق، فشرفنا حضوركم إن شاء الله جميعا هنا. عربي إنجليزي.
realize that besides omission of the upstream emissions, they ignore also all backup that can be assured only with consumption of hydrocarbon fuel and manufacturing of those batteries or gas-fired backup. Practically ignore end-of-life recycle, and what is even more troublesome, they artificially increase denominator. So they postulate fake capacity factor, which is in their analysis taken for south of Italy. They postulate artificially long lifetime given by the manufacturers, whereas in reality it's at least 2 times smaller. So overall, by artificially exaggerating nominator by 2-3 times and decreasing denominator by 4-5 and more times, they underestimate real carbon footprint at least 10 times. So these figures coming from official publication of International Energy Agency are fraudulent. So how they are applied? Suppose you are somewhere in United Kingdom. You install a solar panel and it never performed for technical failures. They would apply this emission factor, whereas real carbon footprint is all carbon emissions from upstream manufacturing. And this methodology is fundamentally wrong. It needs to be changed. And most essential thing, Paris Agreement is about limiting the growth of temperatures. There is assumption that decarbonization may eventually help with this task. But if we look at those climate cooling solutions, they warm climate much more due to non-CO2 related factors. And there are all necessary proofs in academic literature with empirical data. So that brings me to review the foundation, like first principles. It's when you got a negative result in science, it's also a good result. So you have to restart from the beginning. So I suggest for everyone to look at this official definition of climate and climate change. So what is climate? By definition, it's a local phenomenon, and it embraces all types of weather indicators, pressure, temperature, wind direction, and what we are doing with climate solution, we change climate. And if we look at climate change, it says that every single CO2 molecule emitted by a human being or industrial infrastructure causes climate change. So how can we avoid climate change? It's only through carbon accounting fraud or complete extermination of the human race. So I have my conclusions. Global warming and climate change, there are 2 different things. Global warming, or better say, regional warming is real, whereas climate change is a very artificial construct. And I think it was invented to give more power to policymakers, essentially in the Western world, Europe, US, to have more control over regular taxpayers. And what I recommend for Saudi Arabia is a no-regret strategy. Several points. So I admire the wise decision to concentrate on tree planting, because what happens from the point of view of climate science, desertification is a phenomenon specific to periods of global cooling, not warming. And this is where we're heading in the next maybe 20, 30 years, given the solar activity cycles. So in this situation, tree planting considered as a climate mitigation solution according to United Nations Framework Convention on Climate Change, and it's a meaningful solution under United Nations Convention to combat desertification. And then, of course, global like nuclear power is a way to go. I only want to recommend concentrating on meaningful gigawatt scale proven solution from established manufacturers rather than chasing with small modular reactors. And concentrate on meaningful environmental problems like particulate matter pollution in the cities. Energy efficiency is always good, so I congratulate everyone who is doing great research in this area, who is learning or want to learn further, and thanks for your attention.
Yeah, you can take it. Thank you, Doctor. It's amazing presentation, but you know we have a limited time. Okay. Our next speaker, Professor Hassanein Chaudhary, Professor of Environmental Engineering from Al Qasim University. Please join me in welcoming Prof. Hassanein Chaudhary. The floor is yours, Doctor.
Assalamu alaikum everyone, and I'm really glad to be part of this conference. I've found so many interesting people here, and with this medium size of the conference, it allowed us to communicate with each other much more than a very large conference. So I appreciate the organizing committee and King Khalid University as well. We need to move down from a very large aspect of carbon to a much more practical and acute issue. When I was doing my PhD in Canada, so we were not drinking tap water. So instead of just opening the tap, kitchen tap, and drinking it, we were using activated carbon filter, which basically was reducing the chlorine, which was added more due to inadequate treatment of source water. So lakes at the top level, they are free of sediments, and the municipality was taking advantage of supplying that water with only chlorine to the city. So when I was working on the water distribution network of that area, and I found that lack of treatment was the cause of not drinking tap water. When I reached to Saudi Arabia, so again, that was my question, like now I have to build up my research. So I asked my class that how many of you are drinking tap water? So most of the class, they did not raise their hands. And very few raised their hands, and some of them raised and lowered down. That showed the lack of confidence on the source water, on the supplied water. So the problem was not here the lack of treatment. It was something else, because we are using highly complex desalination, either for the seawater or for the groundwater, reverse osmosis. Problem is multifold, so I will try to explain different aspects of that. We know that, so it's about the carbon, water, energy, and carbon nexus of our water supply systems. To build up the problem statement, we can see that we are relying on seawater and we are relying on groundwater. Saline water is way high, no need to explain the level of TDS there, but groundwaters, I read a lot of studies, and most of the shallow and deep aquifers have TDS levels greater than 500 milligrams per liter, which means that they are violating taste guidelines for Saudi Arabian drinking water quality standards. 50% of the water, as per the available literature coming from the desalination, 40% from groundwater, and 10% of the water is surface water where we have fresh water where we have availability. National Water Company, along with so many other partners and the municipalities, are using desalination and reverse osmosis for seawater. And next, please. And Saudi Arabian government is, instead of looking at the numbers, we know that both of the processes, they need very large energy. Desalination more than reverse osmosis. When I'm saying desalination means thermal desalination. They are complex. They need people. The government is spending money on the energy, on cost, on the complexities for both of the processes. Next, please. Still, as per the reported literature, 35% of the consumers in Saudi Arabia are using home purifiers. 60% of the households, they are using bottled water. Could be plus minus, we can have a plus minus 5% standard of deviation here. And only 5% they trust on supplied water. So going into the deeper problem, I went through the water quality analysis, one of our grad student research, from the source to tap, where the water supply was intermittent, means that not 24/7. In the next slides, we will discuss a little bit of that. So we found that when the water is leaving the treatment plant, it is meeting all the drinking water quality standards, excellent water quality, better than probably our bottled water, or at least equal to that. Taste is good, no color, no salt, no issue. But when we took the samples from the distribution network, we need to understand that when we do not supply water for 24/7, the pipes remain empty for, in certain region, for example, in our case study area, 5 days a week. When the pipes remain unpressurized, so all the anomalies in the system will allow materials like sand, pathogens, and other things to enter into the distribution network. Number one, when we further moved, so we can see the red, how the water quality started failing as we move from the supply water to the distribution network. We further went down to the underground storage tank, which we have in our homes. Asir, probably I'm not that good in the, I'm not familiar with the distribution network here, but a lot of areas in Saudi Arabia are using that concept of underground storage tanks, and then pumping the water up to the rooftop tank. And when we took the samples, we found further deterioration of physical, chemical, and microbiology because of the lack of samples, but we have other studies showing microbiological failure as well. Chlorine completely vanishes. The problem is still, if we see most of the presentations, most of the research publications, discussions, they are always on the treatment side. So thermal desalination, how we can improve it, how we can improve the membrane processes, how we can reduce the energy of that, so on and so forth. Less focused is on the distribution side. So intermittent supply, in addition to the water quality failures, it does much more than that. It increases the potential of structural failure. It reduces the completely absence of chlorine, which finally leads us to lack of confidence of using the tap water. Customers are not satisfied. Who is happy to buy a 20-liter bottle and move to the third story of the building? So we have those issues. But why we are doing intermittent supply? That is the question. As long as developing countries are concerned, because I am originally from Pakistan, energy is a major challenge there. But do we have really energy as a challenge here? We are using energy in so many other sectors. The asset management. The whole network, which spread all over the city, we our municipalities are doing two things. Either they are doing the 3 years maintenance program in which they reduce the leakage to 10% of acceptable standards as per Saudi guidelines. And then the next step is the emergency response. Emergency response comes once we receive a call from a customer that I found some leakage outside my home. And the municipality response obviously is fast, but they go and fix it. But there are a lot of other places where the leakage is always happening. Leakage is the hottest area and now identified by the red area by RDIA. So maybe there is something over there also on the right side, if you press that again. Yeah. So I continued my research on leakage as well, and we found that the leakage, because most of the pipes are now plastic pipes, especially new neighborhoods, even 20 years old neighborhoods, the leakage is primarily occurring at the service connections, which are much easier to maintain. And once we do the proactive maintenance instead of emergency response, we can reduce down our leakage. Once we reduce down our leakage, we can start continuous supply easily. The discussion for this conference, more about the carbon, and so that was my recent research, that really low carbon footprint is there because of lack of energy use in intermittent supply, or next, or we have to think about that. So next please. Yeah. So what is happening more? We have different types of intermittent supplies. The red one and the bottom is the one we use in Saudi Arabia, or at least in the Qasim and Riyadh regions, where we supply water few days a week. But there are other types, few hours a day or one time a day. Next please. So I'm talking about 2 days supply in my remaining research. Now this diagram, we all need to appreciate the overall energy use. If we see the system, expand the system boundaries to the end user and the drinking water at homes. We know that there is a distribution pump that is supplying energy either for continuous or 2 days. The left side is showing that continuous supply is using only that energy, and once you have 24/7 water available in your house, it's very important to understand. It's for every one of us. So once we use 24/7, and some of the municipality in Qasim, they started doing that, and I asked the users, so what they have done, that they have closed the valve which was going to their underground storage tank, and now the water with reasonable head is reaching to the 3rd floor of their building. So now the water is freely available in your tap. It has chlorine. It was, the pipes were not unpressurized, so water is drinkable, and if you take the sample, you will find chlorine there and no physical or chemical water quality failures. On the other hand, what we are doing is the right one. In addition to that, we are moving the remaining energy to the customer, because every customer is using a household pump. And once they are using the household pump, the overall energy carbon footprint, we are adding energy to that. In addition to that, once we have storage, we don't rely on our, give me 10 minutes call, please. So when they don't rely on the supplied water, either we go for the drinking water bottles or we go for the home purifier. So this is what is happening. However, the life cycle cost or the energy and carbon footprint should not be ignored of the home purifiers and the water bottle production. So the model is much longer. We need to consider intermittent supply, many more aspects of energy utilization. This was the area. Intermittent supply, 2 days. Ground level was around 50-meter difference and 379 customers were there in that area. You can say the meters, 379 meters. Please, next. So the problem was the energy for the distribution pumps was easily available from the municipality. But what about the energy used by the pumps in the houses? So we did a survey and we found that there are 32 different types of pumps which were available in the Buraida city, Unaiza city markets, and people based on their needs or their little understanding of the flow and heads, they used to buy, they are buying the pumps with, they do not know how much we need and how much head and flow we need. They just buy probably from Italy or Germany, the better ones. So this whole thing makes the problem the stochastic parameters, especially the household use pumps. So we took the area, we did hydraulic modeling, we get the water consumption, and when we got the water consumption, we again found a large variation in the area depending on the household size. So there are houses where only 3 people are living to the houses where 10 people are living. When the household size increased, the number of operational hours of the household pump increased. So that whole thing converted the problem into a probabilistic or stochastic problem. Yes, sorry, please, next. On the right side, we can see that the variation of the household pumps operating time. Small household size around 20 minutes to more than 35-40 minutes for a household with a bigger size. So bigger households are contributing more to energy as well as carbon. I'm not going into the probability distribution here in the details because of lack of time. After the presentation, if anyone wants to discuss that, next please, we can discuss that. This is a very interesting finding. There are 4 lines. The last one is the 24/7. That is clearly showing that 24/7 supply is using more energy. However, the first 2 lines are showing the energy used by the distribution pump for intermittent supply plus the energy used by the household pump. And the blue line is showing the overall energy for 2 days supply. If we see on the top, 2 days supply is surpassing the continuous supply energy, and that actually corresponds to the larger household size. So straight away, operating your pump only for 2 days, municipality is happy, thinking of from energy point of view, instead of operating their pumps for 24/7, still the overall energy is more in case of 2 days supply for the larger households. Next, please. The previous analysis was done without a water loss idea putting into the picture. Here, the different scenarios were analyzed from 0 water loss, which is hypothetical, to 10, which is at the beginning of the proactive measure, to 30, which is our common case in Saudi Arabia. 30% water loss is common, and imagine the amount of money and energy we have spent on desalination. So we see that there is around 37% increase in continuous supply with the increase in water loss also. Sensitivity analysis were performed, 100,000 simulations identified that in the whole probabilistic model to assess energy for intermittent supplies, household pump operating time is the most crucial factor here. 45.5% contribution to the main outcomes. Please, next. Now, talking after Dr. Dennis' presentation about carbon is, I was talking with him also yesterday. I agreed with most of his ideas. but with we cannot leave that assessment in our decision making. And he agreed with me. Rationally, considering all the aspects of sustainability, special social aspect, which is mostly neglected in the smart city concept, we have to be careful in that. So we see there that, sorry, the previous one. Yeah, so we can see that, again, almost in the carbon emissions, the same is the situation. The 2-day supply is surpassing continuous supply. Next, please. Yeah, so after that analysis, we added the energy utilization for the production of 20-liter bottle to be more optimistic, not going for the smaller ones, because these ones for 20 liters, it is another scenario. 20-liter bottle production, the energy requirement over there, and the energy requirement for the household size pumps, we found that 2-day supply, only in terms of energy, is using 2.6 times higher energy than continuous supply. So the whole myth of saving energy with 2 days is not workable once we are using other sources of drinking water supplies. So what is the conclusion? The whole idea here is to obviously reduce the carbon emissions, but my research question is much bigger than that. It's the whole research is perfectly aligned with Vision 2030, provision of safe drinking water and high quality sanitation to the people of Saudi Arabia. Reduce the carbon emissions. It complies with 5 SDGs also, but what are the issues here? So we are lacking consumers, customers' confidence on our water supply. Number one, people are not happy to transport water from the markets, calling maintenance people to fix their household purifiers on routine basis after a month or 2 months. No one likes that. So instead of controlling water loss by reducing the time of pumping, we should move to proactive maintenance. Now, proactive maintenance, I will take just 2 minutes. Those who are listening the whole, they will get it. Now, why we are not doing proactive maintenance? The problem is, one of the problem is our municipalities are highly subsidized, or the whole water supply concept is highly subsidized by the government. The water rates are low, and whatever they are doing in terms of active leakage control is already much more they are spending. So if we move from the active leakage control to passive leakage control and following more asset management practices to reduce down the leakage and to move to the 24/7 continuous supply, we need to contribute, help our municipalities as well. So in future, if they are going to raise your water bills, please be happy to share with them. Finally, we will get high quality water. We would be able to open our kitchen tap, drink the water, customers will be happy, low carbon footprint, and I hope all of us would be happy with that scenario. If you have any questions, probably we have the panel session also. You can see me after the presentation. All of these papers about the leakage and water energy carbon nexus, as well as source to tap water quality, have been published in reputed journals. So if you want to have the titles of them, yes, we can. Thank you very much.
Thank you, Professor Hassanein. Our third speakers, Professor Atiq Rahman, Department of Geography from Jamia Milli Islami from India. Please join us. Floor is yours.
Assalamu alaikum and very good morning. I'm honored and happy to be at this King Khalid University, Aba, the beautiful place, beautiful people, and very impressive university. I must thank the entire organizing committee team for inviting me to this place. So I'll be talking on a issue that we have assessing environmental impact. What impact we are facing today in third world countries and entire world. So with that view, I put a title that in urban setting, because the urban areas and urban issues are posing serious threat to the climate change and environmental impact and environmental problems. So with that view, I put a title that we need to understand the problem at the micro level and at the macro level. And in that, there is one important tool that we have not seen in the last 2 days, that is geospatial technique. Yesterday there was some component by one speaker. So in that, how this GIS and satellite data helps us to understand and to solve the problems. In that issue, let me begin with a problem quote. The next please. I'll put a quote, a very important quote, that is Earth's limit. What it says, the Earth is finite, and its ability to provide food is finite. To provide energy is also finite. We have a lot of session on energy and a lot of nice paper on energy. Then another issue is its ability to absorb waste and destructive effluent is finite. Where we should put our waste, that's also very important. The important common word in this is finite. And somewhere we are missing this finite word. We do not feel that the earth is finite. We feel that earth is very wide, very vast, and we can do whatever we wish. But no, my dear, I feel that this earth is very finite. The productive land is finite. Very limited land is there to produce the food grains for the increasing population. There is a very few areas where we have the good quality of water. So this word, common word, is finite. Somewhere we are missing, and we need to understand, we need to think on this issue. Okay, this is finite. Next, please. Now, moreover, we are fast approaching the many of the Earth's limit, this finite. We are fast approaching, and we do not feel concerned about it. That is my opening remark. And if we do not think about it, we are going in a way, we are going to damage the earth, which is going to be beyond repair. We cannot repair it. If we get a cut on a hand, a small cut, we get it, we put something. But we get major accident, that takes long to heal. In the same way, the earth, finite resources, and earth, the use of resources which we are doing. So in that way, we are fast approaching its finite resources, and then we are damaging the earth. We are going down and going to pump the water further with the technological advancement. So in my talk, I'll be talking on three issues. One is economic growth, second is population, and third is a problem which is going to come. Next, please. So if you see the population, if you see the global population of the entire world is one color. 2011 data, it says 7 billion. At the present, it is 8.3 billion. So, slide please. So what we see that, next please, keep pressing. If we see the continent-wise population, next please, we have the largest population in share in Asia, next please. If we see the country-wise, next please, what we find that, next please. If you see the countries like India, Southeast Asia, and many other countries, China and all, which have very high population. Next, please. But this does not give you the good picture. The good picture, what we get from, next, please, when we try to get the ratio figure, that is the population density. Next, please. This is the population density. What we see is where all the population is. And we always try to blame the population as the main culprit. But I, as a student of Javi, do not feel that population is a culprit. Population is a resource. Population is a resource. Next question is, what kind of population do a country has? If the country's population is skilled, qualified, educated, then it becomes an asset. If not, then it becomes a liability. So this is very important. So I do not blame the population. China and Japan has a large population, but they do not have any problem. We blame many other countries that large population is a problem. Next, please. Now, next, please. Now, if we see the population of urban areas, next, please. Click on to save time. Now, with the increasing population, this slide shows that land is shrinking. The population share is reducing. And if you see the total trade value is going up, GDP is going up, CO2 emission is going up. So on the right side, what it shows, the issues which we have. On the left side, what we have, the globe. Earth is not shrinking, Earth is the same, but it gives a glimpse that it is shrinking. Next, please. Now, if you see the global scenario of urban population, because as I said that it is urban population, urbanization, that is the main issue. So if we see the urban population in the world, global scenario, in 1900, less than 15% people were urbanized, but by 2030, more than 60% people is going to urbanize. Now, I'll escape the Indian issue. Next, please. Now, if we see where all they are distributed, we do not need to look into the values. We need to say where all, what type of distribution is, a special dimension, distribution of population and in resources, that is very important. If you see the population, world urban population, if you see the top left, in 1950, many of the Asian countries, African countries were having less than 25% population, but by 2018, the population increased to 25 to 50, and by 2050, most of the countries across the world, they are going to have more than 75% population. Because nobody wants to live in the urban area, rural areas, especially in the third world country. They keep on moving, and therefore, they are pressing and putting the pressure on the resources. Because consumption of water or any other resources in urban areas is much, much higher compared to rural areas in India and many other countries, especially in the third world. Next, please. So, if we see the economic growth, world economic growth, what we see, the GDP from 1982 to 2018, faster economic growth is very good. Next, please. If you see the nominal GDP of the country-wise, China, Eurasia, and United States, they are going up. So economic growth is very good, but in what way, in what fashion the economic growth is taking place, that is very important. Next, please. So when the money will come to our pocket, what will happen? Obviously, we are going to the market when we are going to consume the resources. The material consumption is going to increase. So if we see the population and material consumption, what we have, the population is increased double, but material consumption is increased 5 times. So that is a big problem. So if we see the future demand, there are different scenarios. Because of time, I'm not going to detail. Because of that, the population is going double and material consumption is going 5 times. Next, please. So when the money will come to our pocket, what will happen? Next, please. This is going to happen. The left side is the production system. 24/7 factories are going up. N number of pollutant is being released in the atmosphere, in the water. And the right side, you see the one example that if we talk about India, if you do not have the house, if you do not have a good job, but still people go and buy a car. So next, please, what will happen? Energy consumption will increase. How the energy consumption will increase? Per capita energy consumption we see from 1960 to 2010, what we have. For the many of the countries, especially developed countries. The developed countries are consuming energy at a very high rate since long. But if we talk about India, the energy consumption is very low. Next, please. What will happen? When the energy will be consumed and fossil fuel will be burned, what will happen? Obviously, the global earth temperature, global warming, this is a very important issue. That is a very serious issue that is happening across the world. One needs to understand that. So what is going to happen? This is going to impact. Now we have the power of remote sensing and GIS data. From here, I'll be showing some of the case studies that my research team is doing. Next, please. Next, please. From 1972, the first time we have got the satellite data, that is Landsat 1. And then we have the series of Landsat data, and that is highly used in different fields. Next, please. Now, if we see the Indian satellites program, it was 1988-89 when the first satellite was launched, and from then onwards till today, we are getting very good quality of data. Next, please. Now, by using these satellite data, what we are doing? As my title says, from micro to macro level, I'll be showing some studies, case studies, which is very important, and that one need to understand. And one important issue that I want to convey before the audience is that we need to
study the smaller cities and medium cities as well as the larger cities and regional level. Because the smaller and medium cities constitute a large number of population in urbanized world in any of the countries. So we do lot of research on the large scale, but we do not study much on we do not do much project on the smaller cities. So therefore, this is a very famous city, that is Hyderabad. If you see the light side, top left figure, in 1971, the small blue patches, that is water bodies. And water bodies are the lifeline of the population of any country. In 1999, it reduced. Next, please. And by 2001 and 2005 and later on, it all vanished. So at one point of time, what I said, that urban population is the main issue where we are using the large number of high amount of water for our domestic and other uses. So what we are doing? We are pumping the water and water recharge is not there. My earlier speech was a very nice presentation he made about the water. Water is elixir of life. You forget about gold and diamond and all. If there is no water, you cannot survive. So we do not feel concerned about it. In a hotel, they say, save water, but we do not save water. See what we are doing. So I'll come to this point in the last. So this is state of affair. There are a lot of water bodies and that is gone. And that is, later. Next, please. If you take the Aral Lake, which is one of the world's freshwater, one of the largest freshwater lake of the world, this satellite data analysis, this no analysis is a simple picture. From 1977, the black patches shows the fresh water. Now if we go to 1989 to 2006 and 2014 and 2024, it is all gone. From where it will come? So we do not recharge it, we are extracting and using and wasting it. Next, please. Next, please. Make it fast. If you see the Arctic Sea and ice, because of global warming, what is happening? The snow, next, go back, please. If you see 1984, there's white patches, large white patches of snow and ice cover. In 2011, it reduced, and by 2024, it is further reduced. So snow ice are the reserves. And we are somewhere, because of global warming, because of human activities, are doing in a way that it's all being melted and it is going to river and then ocean of no use. The water is of no use. Next, please. Then this was on a water issue. We did some studies on the urban transformation, urban land use change, and the vegetation. Next, please. I'll not go to the details of all. I'll go to the output. Next, please. This we did two analysis. One is the built-up area, built-up density. Earlier, in traditional time, what we used to do, we used to have a land use land cover map. But with the advancement of GIS tool, what we used to get, the built-up density and built-up intensity and the rate of built-up change. And the second, what we have is the built-up density. What we see in the north of this is for the Delhi. On the north of Delhi, what we have, if you go from 1991 to 2021, there's large concentration of built-up density. Why? Because of the cheap land. And it was easy to build houses and industrial activities. So if we go similarly built-up density, what we'll find, you'll find what is the state of change of built-up density and all. Next, please. Now, similarly, if we go to vegetation density, how things have changed. So what we see, at one point of time, built-up is increasing, and at the same time, similarly, side by side, vegetation density is going down. So what is impacting? It leads to climate change, microclimate change, unhealthy climatic condition in any cities, be it Delhi, Calcutta, anything. Next, please. Now, we try to see the land surface temperature, LST. Professor Javed has done remarkable work way back in 2005. He was a pioneer of LST and urban heat island study that he's done. So in that, what we have seen, temporal pattern by using thermal satellite data from 1991 to 2018, what we try to see, what is the state of land surface temperature, and right side, surface urban heat height intensity. Because there is not a surface temperature, we need to see the surface heat height intensity, at what rate it changes. Next, please. Now, we took the thermal infrared camera and we try to see, this is another study, we try to see, because in cities, urban areas, what is happening? The construction material is changing. Earlier, the construction material houses are very eco-friendly. But now things are changing. It's all going to be steel, glasses, and concrete, different type of concrete, marbles and all. Because of that, what you see, the state of urban environment, the microclimate, for which the people are exposed to all the year round, 24/7, that is impacting a lot the quality of life. Next, please. This is another, these are the different locations. On the left side, what you have the picture from the field, and the right side, the satellite data, thermal infrared camera. By using thermal infrared camera, what we have, the different location, what is surface temperature in a different time period. Next, please. Now, this is the one aspect. Then the second aspect, we try to see, the new concept has come, the impact of blue-green spaces on the cooling environment of city. This is another city that my PhD students are doing. Next, please, where we try to see the cooling capacity of the, how the cooling capacity of a particular location, particular area, the green parks or blue spaces, how they are impacting, playing positive role. So that is another very important issue, and that is very important applied work that we are doing. Next, please. And I'll now go to the detail. What we did, we took different, locations. Say, for example, when we have the different park, Vidhan Sabha and all, if you see the right side bar graph, this name are there. What we see, the average temperature reduced to 2.51 degrees centigrade. So imagine 2.5 degrees centigrade if because of the greeny space or the water bodies. Calcutta is a city where a lot of lakes and ponds are there because they promote fishing. So because of that, the temperature is reduced, say 2.5%. We had a different concentric rings of 30-meter interval. We made a buffer and we tried to see how it is impacting. So we try to compare the blue-green spaces, areas where we have blue-green spaces, and the areas where there is less blue-green spaces. Next, please. Now, we try to build a relationship between different, parameters. Distance from the blue-green spaces, when we go up, go away. So what we have, if you see the trend line is going up, and that shows a positive relationship between blue-green spaces. Next, please. Next, please. I'll escape this because see, power cooling, one aspect is power cooling, PCA, and the second is power cooling efficacy. We try to see what is the power cooling rate and what is the power cooling efficacy of all those study points. Next, please. These are the, we applied shape modeling, that is advanced modeling technique in GIS, and we try to see which factor is most important. In that, if you see the top left figure, normalized differential built-up index is playing very important role, and normalized differential water index is also playing very important role. Next, please. Escape this one, please. Next, please. Now, the third and last study is a global study. Up to now, what I showed you is a study that has been done at the city level, the big cities and medium-sized cities. Now, I'll go to global level. In a lockdown period, what we thought of, let us see what impact is going to happen, because when the economic activity is shut down, all the factories are shut down, all other economic activities are closed, what impact is going to happen in the global climate, global atmospheric air. So in that case, again, the power of remote sensing is that there are two very important satellite data. One is a MIRA, that is Moderate Era Representative Analysis for Research and Application MIRA. There are different series of MIRA 1 and MIRA 2. And then another satellite data is Atmospheric Infrared Sounder. We use these two satellite data. Next, please. And we try to assess the different particulate matters. Carbon dioxide, carbon monoxide, black carbon, CO2 and all. So next, please. So what we got, we try to see the global mapping, carbon monoxide. This is very important study, is published in a very good journal. What we see, the carbon monoxide was 1,232 to 2.205 part per billion by volume, ppb, but which reduced to 59 to 101 in most of the Union countries. If you see the darker shade. So this has impacted, that has been result of slowdown or closing of economic. Next, please. Then what we did, we took 4 times satellite data. One is December 2019, then January 2020, then February 2020, and March 2020. So these 4 maps of global, we try to see, if you see the right side picture, both the pictures, the dark shade has gone. Why? Because of concentration of CO, carbon monoxide has reduced drastically. Next, please. Next, please. Then aerosol we try to measure. Next, please. Aerosol also gone down from 1.72 in January to 0.6, that is almost half, it reduced to half. Then if we go and see the index, and we will find what is the state of our. Next, please. Then we try to assess the ozone, and you can see the picture, and you can get the glimpse. In all the parameters, whether the ozone, CO2, CO, it has reduced drastically. Next, please. Next, please. Then PM 2.5, that is very important parameter. Next, please. Then we have a black carbon. In the black carbon, what we find the South and Southeast Asian countries like India, Bangladesh, Pakistan, Myanmar, Thailand, Indonesia experienced a huge reduction in black carbon during 2019 to March 2020. Next, please. Then by using all these parameters, there are certain other parameter we escaped, I did not put it. By using all these parameters, we try to get the final figure in the GIS modeling, and we try to get the air quality index, AQI. And if you see the air quality index, state of environment global level, in the month of December 2019 and 2000 January, the pollution level has reduced highly. But it decreased considerably after when we have the lockdown and factories closure. So the question is, do we need to close the industries to reduce the pollution? No. My answer is no. How we need to produce our goods and services so that our emission get reduced. That is the answer. Next, please. Next, please. Move fast, please. Then we try to make the matrix. And if you see the left side 4 columns, December, January, February, March, and then we try to see what is state of affairs from December to January and December to February, and so on and so on. So if you see the right side, we have the lighter shade, and the extreme right, we have the index. What it shows, in which country and what has happened. I'll finish in a minute or two. Next, please. Now, way forward, since we talk about the water, I give one key solution, that is rainwater harvesting. And rainwater harvesting, if we say this is small building in the circle, it has an area of 1,115 square meter. And if we take the annual rainfall is 2,000 millimeter, and if we harvest from that building, small building, how much water we can generate? 2 million liters of water. But in India and different countries of the world, all these fresh water, rainwater is going to the drains and getting waste. So this is one way forward solution. Next, please. Now, this is last slide, sir. So what should we do? The point and the studies what I showed before you, what we should do. Now, what should we do is a big question. Should we keep a business going as usual in the name of development? Everyone talking about a faster economic growth, everyone talking about a development. Should we keep going in the name of development? Can global leaders and central government take proper effective measure and mitigation? Do we feel that it is only the government or state and central government? Can we do something collectively, individually? It is our own responsibility as an individual. And I feel that if I do individually something and contribute to the reducing the impact and all, and to save the water energy, I can change the world. Next, please. Next, please. Fast. Make it fast, please. Next slide. Alarm is already on and rising continuously. When we wake up from our routine work and feel concerned about the environment, that is a big question. This is a $1 billion question, but no answer. I do not have any answer. Maybe audience may have an answer. Next, please. So what we have in the last 2 lines, if I say, next, please click on. If we are not a part of solution, then I say that you are a part of problem. So I say that please wake up and become a part of solution as an individual citizen. Be wherever you are in India, in the case, Saudi and Canada, and try to feel concerned about the environment and make environment, because it is not a government which is going to do everything. It is our own. If we individually do something, we can change the entire face of the environment and nature. Thank you so much. Next, please. Thank you.
Thank you, Doctor. Now we'll have the 4th panel discussion about the environmental impact, remediation policies, impact and assessment and sustainability treatment. The panelists, Prof. Alexei Bulukev and Prof. Wael Ahmed and Prof. Hassanein Chaudhary and Prof. Atiq Al-Rahman, and moderator for this session, Prof. Jafid Malik. Please join me in welcoming panel and members. Mr. Prof. Alexei.
Hello, very good morning. And assalamu alaikum. Myself, Dr. Javed Malik, and here I'm the moderator of this panel discussions, and I welcome to this distinguished professors, Professor Alexei he's from Emirates, Arab Emirates, Dubai, and Professor Weil is from Canada, and Hasnain Haider from Qasim University, and Professor Atikur Rahman. Welcome for these sessions. The panel discussion, the title of this panel discussion, it is about environmental impact remedies. We will talk about the policies, impact assessment, and sustainable treatment. So let's start with the first questions with Professor Alexei. As per your presentation, sir, given that AMP-cycle's cooling tower can reduce the temperatures to 10 to 25%, and it is saving more than 136% of energy. So what do you see the biggest policy barrier preventing the rapid adoptions of such breakthrough technology in water-stressed region like Gulf or Saudi Arabia?
Thank you for your question. Assalamu alaikum, kif al-hal, and I'm happy to continue line of presentation from yesterday when I presented our development in Saudi Arabia in terms of alternative energy and alternative innovative transportation with Fly Now. And for example, one of the topics of development of Fly Now Arabia is to establish sandbox for government, for authorities to have regulation improvement to afford, to approve, and to implement alternative transportation as flying vehicles, e-copter, for example. It means the business development rely on main factors like legislation, regulation, codes, and standards. And best startups do a lot of efforts to improve regulations to afford new innovations. It's first topic. Second topic, from our experience, corporates worldwide, not only in Saudi Arabia, but worldwide, are very keen to implement and introduce new innovation if they could deliver better result for less money and faster. But not all corporations are happy to work with startups. And traditionally, according to practice, there is death valley for startups when they have already product but do not have clients. The same is another death valley in innovation. We, for example, have enormous breakthrough product, but we have a problem, we have a path to get to corporates to implement this innovation. And of course, big corporations prefer to deal with product from some vendor with certified material rather than spend their time to build up, to grow up innovation inside. And institutionally, there is a very interesting instrument called corporate accelerator. There is accelerator ecosystem, innovation ecosystem in Saudi Arabia already, but mostly from government, MCIT, the Garage, MIWA, Ministry of Environmental, Water and Agriculture. And there are also big corporations, and if they have incentive from government to incorporate ecosystem of innovation inside, and more important, if government will make incentive in, for example, taxes or in other supporting means to support governments to implement infrastructures, it will be a more smooth way for innovators like ours to implement these aspects in Saudi Arabia. And just for example, my personal experience, Aqua Power, they only work with TRL 5 innovations. Excellent. They have established innovation center on water technologies in Kaxt, in Riyadh. It's great. But for young, they also have innovation days in Kaust every year. Great effort to absorb innovations. But with government incentives, with establishment of own accelerator, it could be a faster way, fast track for innovative startup to implement it. And it is both way, real from innovation-starving corporations and goodwill from government to support this innovation implementation. Finally, in the legislation, it could be some rules for tenders to make preference for startups or for companies with innovative solution in terms of better treatment on tender. Not only about money, not only about delivery time or qualification, but innovation impact of this technology. So this is my ideas and vision, how path from product to corporation could be more smooth.
Thank you so much. Thank you so much for. So as per the during our sessions, plenary keynotes sessions, we're finding that a lot of advanced technological aspects and research are going on, and it go on commercial products. So what the rules and policies gaps currently slow down our adoption of sustainable multi-phase based technology? And I would like to hear from Professor Weil for this particular issues.
You know, we have a crunch of time, so I'll be very brief. I will just focus on the most important kind of a significant gaps. And it's not only related to Saudi Arabia, but also related to the international community in whole. So most of like regulations actually focus on outcome standards, like, you know, setting up regulation for emission or setting up regulation for water quality standards and so on. And I guess most of the country is basically missing the most important piece of looking at the process innovation, because everybody is actually chasing and running for a new technology. You want to adapt it into the systems, but sometimes actually the new technology cannot fit into traditional systems. So looking at the process as an overall process for regulations is actually much more important. I'll give you an example for Canada, for example. So we are looking into, for example, CO2 capture, but also looking into CO2 reuse for greenhouses application, for growing plants and stuff like that. So the integration of the process and the innovation, actually looking at the process, will be kind of, you know, the most important piece to look at when you develop new regulation or you would like to fill the gap.
Thank you so much. Actually, just I was aware of what you're talking about the water supply. So only the 5% of the people trust the supply water, as your presentation saying. So what can, as a government side, what can government do to rebuild the public confidence and make sure the poor communities in Saudi Arabia don't have to depend on costs? So this is the high carbonized bottles and other things. So what should government to rebuild the public confidence?
Yeah. So is it working? I remember
there used to be a dashboard shown by the municipality in Canada, and if you go to their websites, they will show the water quality situation of their source water and the supplied water, and then the water which is available at the consumer tap. So once we, for example, all of us, if we have access to a dashboard through our mobile phone, and we can see that what kind of, with obviously certain standard deviation, what kind of water is available in our system, and with the evidence of sampling and monitoring, we will have much more confidence on the water supply. How to achieve that? We are moving towards smart cities idea and all the IoT thing and the sensors installation. So where the government need to spend money instead of all the efforts on the desalination is now to improve in the last 5-6 years, they moved from the conventional meters to smart meters. So the next step is to have the whole system smart. So wherever there will be a pathogen or intrusion of something which was not in the supplied water, there should be a trigger at the municipality side. And all those things, boiled water advisories, Professor Weil can agree with me. I used to remember there twice or thrice a year there are in smaller towns. Professor Atiq's about smaller, and my whole PhD was on small systems. In smaller towns, it's hard to, because the lack of resources. But if your municipality is asking you to boil your water like 3 times a year, you don't mind it, or shift to bottled water. But for the 90% of the time, if you can use your tap water, there is nothing more than that. So integrating the whole system, disseminating the monitoring results, motivating people through campaigns, all of these are the strategic changes we need in Saudi Arabia. That means you're talking about the community-based services should be expanded. So more community engagements, workshops, so it will be fill up the gap of the governments and the people together. So it will be more.
I think this is now very easy with the social media, and with our gazette announcing good news every day. We can just tell people that there is already a app or a website available, and you can log into that and you can see the water quality results. And we are moving towards that. If you give me just half a minute, I tell you another aspect of environmental impact of our the side of the water conservation. We are not thinking about the wastewater we are producing. The wastewater we are producing is having only organics, which our existing wastewater treatment plants can easily remove and make it suitable for landscape and irrigation, even unrestricted irrigation. Because the resources we have utilized on desalination is a resource in our wastewater as well. So we should also move, instead of asset management of only water supply system, to asset manage of our sewerage system as well, so that we get all the, it's 50% losses. Over there 30, we have in 50% losses. So the whole water cycle, we have kind of like 45 to 50% water loss.
Thank you so much. Thank you so much, Professor Hasnain. My concerns are in the era of these globalizations and also the economic developments, how to attain the sustainable goal, especially we are talking about sustainable goal, 6 is a cleaner water, and we're talking about SG3, sustainable goal for the healthy, the good health for the developing countries. So how to attain the sustainable goal with these particular things?
Thank you. Professor Javed, these two are the very important issue. As I said in my presentation, that water is the elixir of life. Without water, nothing is possible. No economic activity you can perform. And the second is air, where we breathe to live. So these two issues, if we talk about developing countries, be it India, especially India and other countries, this is going to be on the worse side. We are talking about sustainable development goal. And in India, there is a concept that is called smart city. So in India, government has taken 100 smart cities, 100 cities, and they are trying to make it smart. And that is one part of sustainable development goals. I feel that, and they are expending billions or millions of rupees. And that money is not being properly utilized. I feel that you need to build a solid infrastructure. When you talk about infrastructure, the first important is what Brother Hasnain has mentioned, the pipes supply lines, drinking water, to provide the good quality of water for the people, you know. And the problem what is there, that what I agree with what he presented, that pipelines and supply chain is very weak. So you need to provide the good quality of water when I talk about infrastructure. Then you need to do good transport, efficient good transport. And then when we talk about air, if you see in India, air quality, what I showed here, in Delhi, when I left Delhi, it was more than 500. And all the parameter is more than 300 and 400. And all the year round in many of the cities in the entire developing countries, the AQI is very high. So there is a need to, you know, to make program and policies so that the air quality may be reduced and good quality of water may be provided. Only then we can achieve the sustainable development goal, that is what you said, the 3 and 6, for the clean air and water. Otherwise, we fail to do that. It will all be in the theory, not in practical on the ground reality.
Thank you so much. Professor Alexei, that in your presentations, we are talking about something roadmap that outline the multi-phase development, which is towards the scalable, low water use cooling system. So my question here, how can governments make the policies and rules to better integrate the pilot stage innovations into the national sustainability initiatives, especially for the mega projects? We are running some big mega projects such as NEOM and also the large district cooling networks. So how these things will be, we can.
First of all, multi-stage implementation plan or roadmap is specially invented, created to minimize the risk of corporate client to implement innovations from demonstrative, especially deep tech. We are talking about deep tech. We have initially demonstrated, we can demonstrate physical phenomena. It's great. Let's go further. Prototype or in startup MVP, minimal viable product, is already doing something useful for people or for customers. For people or for customers. And then, closer to business of corporation, it's very crucial to have a POC, proof of concept project, to provide a bridge from laboratory to corporation. And finally, it will be another, like a pilot project, already in scale, fulfillment of needs and headaches of corporate. So it was about multi-stage. About historical aspect for India, for our distinguished guests from India. There are two innovative, well-known projects in India. Tata Nano Car and Bill Gates waterless toilet. I believe Saudi Arabia deserved to have own technology of this international or global level, but more affordable, more innovative, more disruptive, more simple in implementation and in maintenance and in fulfillment. And I believe people's air conditioner could be such a global project of Saudi. It could be based on any technology, but probably it could be based on Mysasenko cycle with enormous ecological, social, and economical aspects, and could be promoted to the world based on Mysasenko cycle, but very own technology of Saudi Arabia, and promoted to the world, proudly created and designed in Saudi Arabia. It could be like another idea, similar like India with excellent innovations. And I can name 3 corporations in Saudi Arabia: Zamil AC, Shaker Group, and Alat Manufacturing. All them do advanced manufacturing, especially Alat with hefty support from PIF. Shaker Group is based on LG technology. It is licensed from South Korea. Alat is talking to Carrier. It is a top international United States corporation. They're happy to establish the research and development center and manufacturing, mostly to promote their unique technology, innovation, verified refrigerant flow. Again, I believe in case of own Saudi technology, it could be a real governmental product to implement this on global scale, using existing infrastructure of Zamil AC or Shaker Group with production lines and new production line and research center created currently by Alat. This is another idea and another proposal. And I believe Saudi could be the first country in the world to implement the unique human right to survive in harsh climate and extreme heat with own affordable, simple, very plug and play and very simple air conditioning system. I believe it could be heard by decision makers in the country.
Thank you so much, Professor Alexei. As per our conference titles, we are providing the environmental solutions. And when we talk about the environmental solutions, so we have a lot of multi-phase systems that drastically can improve our efficiency, our safety, and cost across the multiple sectors. Now, my questions, we have a lot of emerging technology. We just start from the AI-driven modeling, smart sensing, or advanced materials. And they have highest potential to accelerate the environmental remedies. So which most important emerging technology, which technology is more suitable for in this multi-phase systems? Which technology will give more emphasis to utilize?
Actually, my presentation will be this afternoon about multi-phase flow, and you cannot imagine how much is the application of multi-phase flow in many energy, water, and food systems. So from oil transportation to power generation, nuclear, steam generators, it's a massive application, and lots of potential for energy efficiency improvements in these systems, mainly because most of the equipment actually exists so far in major industry are relying on models developed for traditional system using, for example, control volume analysis. You don't get into so much of the details about the multi-phase flow. So one of the aspects of actually improving the efficiency is adapting new technology by looking at, for example, the interaction between different phases like gas, liquid, solids, or like, in food processing, chemical reactions, CO2 capture, getting into much more like, core fundamental physics of interaction between these phases. one of the major emerging technology now, and everybody agree with me that AI is it's a driving vehicle for like new solutions, but is more beyond AI and looking at the data, processing the data, using the data, and integration between different systems. One of them, something that is actually coming up as a trend now in North America is what we call it the digital twin. The digital twin is basically integrating to the digital modeling, improving the models, because now we can process a lot of data, but also integrating the Internet of Things like the sensor, the smart sensor, as Dr. was talking about here. So the digital twin system will be able to predict not only the system performance and then react to how the system is operating, so you can actually change the operation, but also you can actually predict what's going to happen next, so you can actually proactively changing the system operation from now on. So you can actually improve the efficiency this way.
So that means AI-driven technology is playing in future is playing a very important role, because it gives you a lot of solutions with the high level of computer process and a lot of things, so which the people of the normal people, the human brains cannot conceive all the analysis. So it will give the relations a lot of parameters together. So it gives more important aspects for to understand the phenomena, to understand what is happening. So it gives you a proper solutions for this particular things.
And this is basically what I'm going to discuss in this afternoon, unlocking some of the fundamental stuff that were never been able to unlock before. So now with an AI and data adaptions, we can actually look into much more deeper analysis and then come up with a solution for that.
Actually, we are moving for the Saudi Vision 2030. And in this Saudi Vision of 2030, mostly we are highly rely on desalinations right now, more than 50% of seawater.
Yeah.
So what is the rules and policies? We're talking about the solutions. What are the rules and policy reform the most urgently needed to address the energy-intensive water productions, or also an high renewable revenue for the water losses? So how you think, Professor Hasnain, so what kind of the rules and policy we can reform to get to solve this particular energy-intensive water production and the losses?
Yeah. The very, very simple answer. It's just we should move from the existing practices to proactive.
Okay.
That is one line answer to the whole thing. Water is a resource. Once it's become wastewater, it is again a resource and it can be recycled. The idea of digital twin is actually excellent. It can be applied to both water distribution system as well as the wastewater sewerage system. And then all the decisions we are going to make would be based on the large data sets. The decisions would be more reliable, more cost effective, and will help us in proactive maintenance. Our research group is working on all three urban water infrastructures.
Okay.
And recently, one of my PhD student, he developed an IoT-based flood risk management decision support tool, we should say, which will tell us, based on the land use of the area, that which area can be flooded with during the flood, can be flooded with less impacts, socio-economic and environmental impacts, and which area should not be flooded at all. So those kind of, I think the decisions needs obviously strategic level moves as well. And I would say that being proactive would solve most of the problems, inshallah, in Saudi Arabia. Thank you very much.
Thank you so much. We are running with the time, so inshallah, only one question, so I will ask Professor Atikur Rahman. Actually, we are talking about, for me, as a personal way you can ask me, I give more focus on community engagements, the participation of, until your policies, your things will be not accepted by the community, it is not. I always talk about how the community reacts. So, my question is here, how we can address or reduce the environmental impact by public engagements, the community participations to achieve cleaner air, to achieve more clean water, and also to achieve the quality of a good life. So what kind of community participation should we take the initiatives in concern with the environmental impact?
Thank you, Professor Javed. That is a very important issue that one need to understand. We as a scientific community are the common citizen of any country. See what all we do. We are not supposed to do that at that particular place. We are encroaching the riverbeds. We are building our houses on the steep slopes, on Himalayas. If you talk about lower Himalaya, higher Himalaya, across being India or anywhere. So we are not supposed to do it again. We are going and building our houses in the forested areas. That is the habitation of wildlife, not ours. So when there is a wildfire, this is a natural phenomenon, we are being impacted. So it is, as a citizen, we need to feel concerned about it. Okay, what we should do and how we should use our resources, be it a forest, water resource, or soil resource. This is one. Second issue is that, as I said in my earlier talk, that Allah has given us aql, and all the resources are made for us. So it is our own duty, it is our prime duty, whether I'm learned, technically sound or not, we need to understand how to use it. And unless we do not optimize our use of resources, be it any part of the world, Saudi, India or America, we are not going to achieve the sustainable development goals, any of the goals. And all the goals will be failed. All the technological solutions are there if we use it wisely. So Allah has given us wisdom and the resources. We need to use it in a proper, appropriate, in a just manner. And for that, there are two issues. One is those who are, those who know it, those who know all the rules and laws, and those who know the ill impact, but still they are doing the wrong thing. And those who are not knowing, so there is need to build a capacity to make them aware and to use it. And only then we are going to achieve the sustainable development goal. Otherwise, as I may be wrong, everything will be at the end of 10 years, 20 years, things will not be achieved. We may achieve partially, but what we wanted to achieve, we could not achieve. That is my say. Thank you.
Thank you so much. So that means our community participations for the environmental impact and other things is very much important. Until the adoption things, it is ultimately go to the publics. And if the public peoples are our students or our community or all the stakeholders are concerned with this particular impact, so it will be really if they practice to reduce, to how to mitigate the environmental impact, and this is practically we are doing with the student level or as a community level, so that will be very nice to mitigate this type of environmental impact, and we have a lot of solutions. Thank you so much for all your attendance here. May Allah bless you, mashallah. And our students and our other audience are really get some benefits from your all the briefing or all the inputs, whatever you're providing. Thank you again. Thank you very much.
Now I ask the plenary speakers and Prof. Dennis and Prof. Al-Misfir to join us on stage for recognition. So welcome. Now we'll have a break until 1:30. Then inshallah next session will start at 1:30. Okay? Thank you so much.
Good afternoon, distinguished guests, colleagues, and participants. Welcome to plenary session 5, titled Circular Economy and Smart Technologies. It's my honor to serve as moderator for the sessions. We are pleased to host a group of distinguished speakers who will be present their insight of this important topic. Our first speaker is Mahmoud Allah Haq or Mahmoud Al Haq. He's the professor of structural engineering at Michigan State University. The title of the presentation is Use of Lightweight Green Materials, Reversible Joining and Integrated Sensing Technology for the 60s story in the circular economy. Please join me in welcoming Dr. Mahmoud Al Haq.
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. I have the most difficult task of waking you guys up after lunch, and I will do my best to wake you guys up, inshallah. First of all and foremost, I would like to thank the organizers, the scientific committee, the leadership of KKU, and my beloved brother Saad for having me here. It's been an immense pleasure, a perfect example of Saudi hospitality. Thank you very much. Today's presentation is going to be slightly different than what you have seen so far. My goal is to tickle the brains of the students. My goal is to make you think outside the box. So today's topic is more of an example of multidisciplinary research. So when I say composites, what is the first thing that comes to your mind? Boeing 787, I have the Saudi one. You have SpaceX, NASA, rockets, 110 meters GE halide wind blade. Next. We have two amazing examples at Michigan State. The left one is the Formula One autonomous driverless car. We hold the world record for 197.7 miles per hour. Inshallah, in January, we are racing again in Las Vegas. We aim to be the first ones to cross 200 miles barrier, all autonomous. We also have MSU Formula SAE car. All the testing for that car is done in Michigan State in my lab. The reason I am showing this is all completely, absolutely opposite of circular economy. These are extremely resource intensive, meaning if I have to do a carbon composite monocoque, it will easily take 4 days of autoclave, very high temperature, very high pressure to make these things. But then if I have to make this green, if I have to make this sustainable, what is the way to do it? Another example, all of these composites are made out of thermosets, meaning at the end of the life, they go to a landfill. Just like the way we go to khabar, this is the khabars of the aeroplane, the graveyards of the aeroplanes, and the graveyards of wind turbines. So how can we make a use of this? And the idea is, can we design for circularity? Can we design for reuse? And that is where the innovation comes in composites. When you have resource-intensive, costly materials, how can we fully utilize them? So now, with all of these, why do we need composites? Here is an example of multiple reasons why composites are needed. I will give you one example. If you reduce the weight of the car by 10%, you can reduce carbon emissions by 8%. You can increase fuel economy by 6 to 8%. One of the things we think about carbon composites is they are brittle. Absolutely not. If I design them very well, a carbon fiber composite can absorb 12 times the energy of steel. Another example, if I just change the assist pedal of a Chevy Trailblazer, all the Chevy Trailblazers in US, if I take all the cars and I just change one footstep, I can save 2.7 million gallons of fuel in 1 year just by changing one footstep of a Chevy Trailblazer. So that are the advantages of composites. Now the question comes, where is sustainability? How can we achieve sustainability? Next. So there are many ways people are talking about circular economy, and we have seen about a lot of presentations in the last 2 days. People with complete atomic level changing of the green chemistry, how to recycle, and all of these. But what I am interested is, can I design and manufacture in a way that will allow me to reassemble, disassemble, repair, maintain, reuse, and repurpose? So that is where the goal is. As you saw, the graveyards of composites, they end up in landfills. So now there are recent advancements in thermoplastics that can be reheated, remolded, and so on, that I can use for my advantage. So that is the goal of the solution that we have proposed, is design for inspection and design for circularity. Next slide, please. So today's presentation, I want to showcase 3 success stories in Michigan State University in my lab. The first one is lightweight green materials. Next. So we'll focus on that now, and we'll come to the next ones. Next. So we all know plant-based composites, green composites. We have been doing it. We have been hearing it for a long time. My PhD was on this specific topic. For example, on the right, you see helmets. You know, the first question that came in my defense was, Professor Haq, will you wear that helmet? Are you sure that a green composite can be strong enough to protect your skull? The answer is yes, if you design it the right way. Next slide, please. So usually what happens when we talk about plant fibers, you know, jute, sisal, hemp, all of these are continuous fibers, but most of the fibers are usually not continuous. They are short fibers. They are used to mix very well and make homogeneous composites. Now these fibers are mixed with a resin. If you use 100% plant-based resin, then you have a complete green composite, but the problem is the mechanical properties are so low that you can't do anything with a green composite. The other part is, can I use a petroleum-based resin, such as a polyester or an epoxy? But then you're not green anymore. You have better properties, but then you're not green. What is a better solution is, can I take a petroleum resin and blend it with a soybean, linseed oil based resin? So now when I add a green composite or green-based resin, a few unique things happen. The plant-based resins act like plasticizers. They increase the impact strength, but then the stiffness drops. Then what if I add a nano clay that is dirt, literally clay is dirt, and it's dirt cheap? I can buy 50 kilos for $10. So now by adding nano clay to my blend of epoxy and a plant-based resin, I get a new system that has a very good impact strength, has a very good stiffness, and now the nano clay is resisting all the moisture. So now I have a durable green composite. So now here is the results of 8 publications in one slide, okay? So the blue dot shows how the impact strengths go up. As soon as I add, if you can see in the bottom, as soon as I add 90% petroleum resin, 10% bioresin, my impact goes up. You can look at the blue line. But my stiffness goes down. Stiffness and toughness are opposing parameters, and a very good structural composite has a good balance of those. The minute I add nanoclay, my stiffness goes up, my toughness goes down. But in the middle, I have a good marriage of both of them. I have a very tough material and a stiff material, and it is durable. Now, when you talk about green composites, you take any book on green composites, they talk about 3 main things that are limiting green composites. One is impact strength. We address that by adding bio-based resin. 2 is durability, because it can absorb moisture. We address that by adding nanoclay. Then comes the third part, is how do you manage fiber quality? Next slide. What we do here is we take these discontinuous fibers and we were able to make them into continuous fibers, and we can place them exactly where we want using what we call a fiber printer. What you are seeing there is a video of a carbon fiber printing of a bracket. That bracket goes for a Bugatti engine pan. So now I can take the exact same thing, next slide, and click please, yeah. I can make an all green preform. Now, instead of having chopped fibers, random fibers, now I have a complete green composite with well-aligned fibers that competes with glass fibers. So now you have a completely green composite competing with a carbon-intensive material. Next slide, please. Now, why is this alignment important? So now, if you understand composite, these are layered structures that are stacked on top of each other with the layers of glue or layers of epoxy. The weakest link is in between the layers. Now, if I have to make a complicated part, I make a plate and then I cut it open. If I want to drill a hole, I drill a hole. Back one slide, please. Can you go back one slide? Thank you. So what we did is the first one on the top, type 1, is a baseline solid composite. In the type 2, we deliberately drilled a 1/2 inch, 12.5 millimeter hole. Type 3, I randomly placed continuous fibers around the hole. Type 4, I ran a finite element simulation, found the principal stresses, and put the fibers exactly on the path of the load. And type 5 is just for an example. Next slide, please. So what is interesting is, if you look at the pristine sample, baseline sample, 1,000, that is what we have to achieve. The minute I drill a hole, I lose 60% of the load carrying capacity. It's no good. What's the point of having a lightweight, strong structure when you lose 60% of its capacity? Then we put the fibers around the hole, we went back to 83%. But if I align my fibers on the principal force direction, I have a plate with a hole that behaves as if there is no hole. Now you can take a weak material, align the fibers in the right direction, and you can use it for very good structural purposes. What is further important is I can use the same tailored fiber alignment, and I can put fiber optic sensors, I can put copper cables, copper wires, I can heat them when I want to, just like the way you have heated seats in your cars, and I can heal the material whenever I want. Next slide. So that was the first success story of using green composites. We have also collaborated with KSCST and used that to build some of date palm composites also. The next thing is reversible adhesives. Next slide, please. One more. Thank you. So whenever you take a structure, joining is inevitable. We have to join two structures, we have to join two parts, an assembly of multiple parts need to happen. So when you look at mechanical fasteners, meaning rivets, bolts and joints and so on, you add weight to the structure. You might ask me, it's just a bolt and a nut, how much weight do you add? US Office of Naval Research took a wing of a B-12 or a F-12 and removed all the bolts and converted them with an adhesives. They saved 200 kilograms in just one wing of the aircraft. And that leads to a lot more fuel savings. So it's not just the bolts, but the weight that comes through it. More importantly, in composites, as you can see, the minute you drill a hole, the layers start to separate, the load carrying capacity goes down. Now the next part is I can use an adhesive joint. I can connect things with an adhesive. Next click, please. The advantage of adhesives is that the load is distributed over a large area, but as we know about our structural adhesives, it's a one-time bond. Once you bond it, you can't remove it. Then there is a problem with repair, recycle, maintenance, and all of those things. Next slide. So can we have the best of both? Can we have the best of adhesive and something that can be removed, repaired, assembled? That's where we went into reversible adhesives. So what we do is we take a thermoplastic and we dope it with nanoparticles. If I use nanographene particles, then I can activate the nanographene with a microwave. If I use an iron nanoparticle, I can activate the thermoplastic using induction systems. What happens is, at just 2 grams per every 100 gram, we have billions of these nanoparticles inside that act as a nano heater and melt the surrounding material. So I can remotely activate the glue and separate things whenever I want. I can repair whenever I want. I can put things back whenever I want. Next slide, please. So here is an example of how I am applying an induction system and separating two substrates remotely. Right now you are seeing a sample inside a coil. The coil need not be circular. It can be a pancake or a flat coil. Next slide, please. So now when you talk about reversibility, our goal was end-of-life circularity. Our goal when we started this work was not for structural performance. But then when you put the effort, you get creative solutions. So on that slide on the top, the green curve shows what is in the market. 4.5 kilonewton of load, that is the adhesive that is in the market. The dotted black lines are the ones that we have developed as reversible adhesives using high-impact polystyrene. And you can look at the failure surfaces. We have a very high deformation before failure. What is interesting is what we started as an end-of-life solution has now become the structural adhesive competing with epoxies. Next slide, please. So it's good to have reversibility, but it's also important to have performance. So the green bar that you see is our material, and the one that you see in the bottom is what is in the market. 2 clicks, please. So we started for reversibility, but what we found is now we are competing with epoxies. That leads to a lot of new avenues to apply this technology. Next slide. So what we did was we applied the technologies on rotors. Or before I go for rotors, this is the proof that I can targeted heat just the adhesive. If you look at it, I have glass fiber, carbon fiber, aluminum, and my adhesive inside. Despite having metals, which most electrical engineers will tell me, how can metals not heat up in a microwave? We have designed our adhesives to heat faster than the metal, okay? And you can see how it heats up very fast as the power increases. So now I can control how fast I can melt the adhesive, how fast I can heal the adhesive, and so on. Next slide, please. So here is an example of an aluminum to a steel rotor attached with a reversible adhesive. This is an actual supercharger of an Audi car, and we were able to test it for, I don't know how many revolutions, around 70,000 RPM or so on, and we were able to remove it and change it. One of the things we are trying to do is to convert that aluminum rotors into all carbon fiber rotors for the near future for lightweighting and dimensional stability. Next click. So that is a rotational joint. The one that I have next is an aluminum to a carbon 3D out-of-plane joint built with a reversible adhesive. We are able to separate and put that back together. The question comes, where do you see these T-joints? You see them in Boeing 787. These are the ones that give stability to the wing of the aircraft. And the last one is how we pull them apart for design validation. Next slide, please. As I told you, we started with reversible adhesive for end-of-life circularity. Our goal was to separate things. The first video that we already saw on the top left is a 1 inch by 1 inch glass to glass with a reversible adhesive. The one in the middle, the top substrate is a transparent polycarbonate. There's a deliberate reason we put transparent, so go back, please. So the middle one is, the top substrate is polycarbonate, transparent, the bottom is glass, and you can see the adhesive like a C there, inverted C. We are heating only the adhesive. That's a 2 feet by 2 feet panel simulating the door of a car. What is exciting is we started to remove the materials at the end of the lifetime, but something interesting happened. If I can control the amount of EM exposure, I can heal the material. So if you look at the bottom here, I take a lap joint on the left bottom, I take a lap joint and I simulate a bullet hitting it. So we hit it at 5 meters per second and hit the joint, and then we test the joint. So we went from the yellow colored sample curve to red and green. So after the impact, the load properties, because of the damage, went down. And then we healed the material by exposing it to EM, and the blue and the purple colors are the ones that we got after healing. So now we came to a new mechanism, is we can heal materials after a hit. That's the best thing that can happen, especially if you are developing helmets and bulletproof jackets and so on. The next thing happened was if you have a car and you're driving, now mashallah, the Abha roads are very good. You know, in Michigan, out of 50 states, we are ranked top 3 from the bottom in the quality of the roads. So we are 48 in this country. So you have a lot of bumps and fatigue. So what we can do is we can heal the joint after 30,000 cycles of fatigue, as if the car never experienced any bumps. So those are some of the advantages that popped out of this. So we have 3 patents on this technology. The applications are limitless. Next slide, please. So we saw the green materials, we saw reversible adhesives, but the key connection between all of them is integrated sensing. If I want to tell you, if you have a car, you had an accident. How do you know which part of the car is affected by the accident, which ones are not affected by the accidents? If we have sensors and non-destructive technologies embedded inside the system, then I can recertify and I can reuse the structure. Next slide, please. So now we have a very unique problem. If you look at metals and other structures, I can use technologies from outside, but composites, we literally have a paper-thin glue connecting layers of composites. So I have to understand the health of a paper-thin glue. If I put a strain gauge, the strain gauge becomes the flaw. Strain gauge becomes the stress concentrator. So I can't use a strain gauge. I can't use whole field imaging because I don't get the health. The best technology we have is a fiber optic sensing, either fiber Bragg or distributed fiber sensing. The sensors are thinner than a human hair and can measure at a precision of picometers or the wavelength of light. So what we did was we put these fiber Bragg sensors inside the adhesive bond line, and we can see where the defect is. Next slide, please. What is interesting is this is the way we put sensors in the key locations. On the right that you see this black strip is a Teflon defect that we have deliberately created. Next slide, please. What is interesting is epoxies, when they cure, they shrink. So you have a one central wavelength on the top right. You have one central wavelength for a fiber Bragg sensor. What we found is due to the curing, we get 4 wavelengths now. So we thought the experiment was a failure because we should have one wavelength. Why are we getting 4? What is interesting is we said, let's track all the 4. And when we are in the vicinity of the defect, one of those wavelength drops, the remaining 3 remain. Then more stress concentration, one more drop. So now, by putting one sensor inside, we've got 4 sensors by default because of the shrinkage of epoxy. So now we are able to understand how far the defect is. We're able to understand the size of the defect and so on with a single fiber optic sensor. The next thing is, if there are material scientists in the audience today, you develop any adhesive or any composite, you need to understand the rate of crack growth. So now, the way we do the rate of crack growth, if you have run this experiment called mode 1 sample testing, it takes 2 hours to run one experiment because you have to put the gradations, you have to use an optical microscope or a digital camera, watch the crack grow as the load is applied on the sample. What we did is using ultrasound guided waves. We send a wave through the sample. If there is a crack, the wave reflects back. I can measure the time of flight of the crack to go and come back from the crack. Next slide, please. So now, if the blue is what we are getting from a microscope and a digital camera, and the red is the one we are getting from our ultrasonic guided waves. The blue one takes 2 hours per experiment. The red one takes 2 minutes per experiment. So now we can develop new materials very fast. The same concept of guided wave, on the top you have aluminum to a glass joint. We have put a total of 8 to 10 piezoelectric sensors. Each pair of a piezoelectric sensor acts like a receiver and an actuator. And if there is a defect somewhere, the receiver receives the waves faster. And I can plot that and find the exact location of damage by using probability density imaging. So now, why am I telling you all of this? So I can use all of these technologies to measure the health of the structure. I can do preventive maintenance with reversible adhesives. I can separate them at the end of the lifetime, and I can automate them. Next slide, please. So I can automate all of my scanning very quickly. In a matter of 2 minutes, we can scan a full panel and find all the defects. Is the defects growing? Are the defects healing? We can make all of those decisions, go, no-go decisions very quickly. Next slide, please. We can scan wing parts, the strength of the adhesives, the degradation of the adhesives, all of them using ultrasound, and so on. So last 2 slides, I have 2 minutes. What is the future? So this is an additive manufacturing process of applying thermoplastic carbon fiber tapes with heating elements and fiber optic sensors. And on the right, I am developing a chassis for a Tesla with wrapping carbon fiber to advanced aluminum so that we can have ductility and strength at half the weight of the existing chassis. That is where our future goes in designing for inspection, designing for circularity. Last slide, please. So more for the students, less for my collaborators. I'm always available to collaborate. Is the future is cross-disciplinary. The innovations occur at the borderline, at the gray area between two disciplines. You have to go outside the comfort zone. And when you think of carbon fiber and wind turbines and so on, you think of extremely high performance, extremely costly material. It does not mean that they are not sustainable. It does not mean that you cannot do circularity. We have to design for circularity. We have to design for inspection. And we have a saying, whenever people present you with a challenge or a problem that they have not solved, most people look at it as a challenge. You panic, oh, nobody has solved it. For us, it's an opportunity. Every challenge is an opportunity that nobody has solved, and you are the first one to solve. That is the attitude that leads to innovation. Thank you very much.
Thank you, Prof. Mahmoud Al-Haq. Our next speaker is Dr. Ruh Khurram. He's a computational scientist from King Abdullah University of Science and Technology Coast in Saudi Arabia, presenting composable HPC infrastructures of sustainable scientific computing. Please join me in welcoming Dr. Khurram.
I'm looking for you to have 45 minutes. Sure. I'm turning on the. All right. Good afternoon. Assalamu alaikum. Thank you, Dr. Mahmoud, for waking up everybody. Yeah, it was a challenge actually sitting and listening after the talk, but your talk was very nice, and I'll benefit from your nice talk because pretty much everybody is up. I also want to take this opportunity to thank the organizers for allowing me to visit this beautiful campus, beautiful university, beautiful city, and more importantly, beautiful people here. So thank you very much. So I've been working with Dr. Saad Sherani for a while. Actually, we do some casual meetings and discussions. And one day he mentioned that he wants me to come over here to attend a conference. I said, sure. I thought that it is in the area of my expertise. And then he said, after some days, that it's in sustainability. So I said, well, I do high performance computing. I'm from KAUST. Many of you might know that we have a family of supercomputers, Shaheen 1, Shaheen 2, Shaheen 3. And it's pretty much like we buy a supercomputer, we use it, and we discard it. So it's pretty much not circular. So it's perfectly linear economy. So I needed to pivot that how to actually make high-performance computing sustainable. So luckily, actually, I was working as a side hustle in designing and delivering some training and educational sessions, workshops for Saudi universities. I go to different universities. This was another opportunity for me to give a workshop yesterday. I went to KFPM. Tomorrow I'm doing it for KA Care. Over there, the challenge is that we cannot give access to everybody on Shaheen supercomputer because it's restricted. And I took this opportunity to explore the opportunities that cloud computing is offering. So today I'm going to pitch cloud computing as a sustainable computing solution to you. You listen to the argument, and in the last slide, since we are not doing question and answer, I have a QR code, so you can put your comments, you can put your questions over there, and if you're interested, I'll be happy to follow up with you. All right, so this is a very, very high level talk, nothing much technical. It's a 10,000 feet view of the ideas that I'm going to do. But again, I think we will have more opportunity during the panel session to dig deeper. So when we are comparing with an on-prem supercomputer versus cloud computing, we are actually saying, rather than owning a supercomputer, why don't you share it with everybody? A simple idea, good idea. I think it makes sense. Cloud actually claims, there are documented numbers, that cloud computing is more, you leverage more utilization. They claim to be 67 to 70% utilization as compared to on-prem computers, which are probably 30 to 40%. And it does make sense. If every one of you have unlimited amount of money and you want to have your own supercomputer, what will be happening on that supercomputer right now? It will be sitting idle. So rather than doing that, why don't we share it with everybody and then only use it when we need it? So it's a good idea. Increase of utilization means less idle cycles. Less idle cycles mean less energy consumption and less energy wastage. So, okay. Yeah, okay, the next slide, please. So when we offload the burden of providing the power and managing the waste to a big hyperscalers like Google's and AWS, we actually maximize the chance of responsible renewable energy usage and better waste management. Next slide, please. Now, there is a nice concept. In order to understand this elastic scaling, you need to put yourself in a situation where you're basically asking me that, okay, I have these computational needs. Ru, could you please design a supercomputer or a cluster for me? So when you're doing this thing, I will ask you, okay, how many students you have, what they are doing every day, and I will try to spec your computational needs. Once I spec this computational need, you will say, well, normally our people use that much, but sometime near the workshops, we have a peak demand. So when you have a peak demand, you have to design for that. So on-prem supercomputers are almost over-provisioned. So when we are using cloud computing, we don't have to over-provision because we can always use spot instances in cloud. So again, this is at the heart of circular economy, that, well, we maximize the reuse of the computational resource. Now, next slide, please. Okay, now let me define what do I mean by composable infrastructure. For me, it means, based on your computational requirement, on-demand, flexible, and economical HPC resource, only for you, which technically means compute. It will have some CPUs, some GPUs. It has some memory per node. It will have some interconnect, software installed, fully supported. Next slide. Again, we have talked about the motivation, and most of you decision makers, you are familiar with the problem of CapEx versus OpEx. Buying a supercomputer is always a difficult thing because you have to pitch it at a higher level. Buying a supercomputer is very difficult. Every 5 years, you have to dispose it of. Rather than doing a CapEx purchases, it is better. Cloud computing offers an opportunity for you to use your OpEx funds to provide a sustainable computing solution. Next. So again, any one of you can benefit from this cloud computing. If you're a student, you're an SME, you're a startup, you're a professor, if you are running some company, you can benefit from these ideas. Because nobody can actually buy this 42,000 single GPU. It's extremely expensive. It's much better to actually share the resources. Now, what I'm going to do is that I'm not going to go into the details. I'm going to actually assume some of you have asked a question that for a given school or university, can we design a cluster or HPC instance for them? So what we are going to do first is that we'll take a basket of test cases, your typical workloads, and then we'll do some computational analysis on that. And then after that, we will do some projection, performance computation projections, and then we will actually estimate your computational resource. Next slide, please. Next slide. Okay, we'll go fast on this thing. So again, static analysis of rubber seal. Next slide, please. Keep going. Finite deformation, elastic analysis. Next slide. Keep going. A dummy analysis, car crash analysis. Next. This is actually a Nissan Rogue crash analysis, finite deformation problem. Next is a flow around, now we are into CFD domain, flow around a sedan car. Next slide. Internal flow in a backward facing step. It's a fire problem, fire in a room. Next. Atmospheric level, weather forecasting analysis. Next. Seismic analysis predicting earthquakes. Molecular dynamics. And how can we ignore AI, of course? Some image identification, CNN-based test case, and large language BERT test case. Next. So the point over there was, next slide, please. Next slide. Next. The point till here was that these test cases represent a very wide range of application. These are not a single professor doing all this research. This is not even 2 or 3 professors doing some research. This is at a college level. So somebody is doing biological research, somebody doing AI, somebody is doing seismic analysis, somebody is doing CFD. So it's a wide range of application that we picked. Next slide. Keep going. Keep going. I'll just pick one test case. Next. One more. Keep going, please. Keep going. Next. Next. Yeah, let's stay here. Now, let's see what is happening here. We take this test case, anybody who's familiar with parallel programming, in order to benefit from parallel programming, does it offer? We run the same problem on different number of core counts. And what we are expecting, the time to solution should reduce. So what is happening here? It is happening, we run it on 32 cores, 64 cores, 128 core, 256, 512, and 10,000, 1,024 cores. What we are observing is that the time to solution is reducing. But beyond 256 cores, it is not really advantageous to keep going there because we'll be wasting the resource. Why we would want to run it on 512 core when it is not giving us the right performance? So for this problem, we say that, okay, for this problem, you should only use 256 core and your problem will finish in 50 minutes. Next slide. Keep going. Keep going. Next slide. And we are picking different core counts for each problem. Next. Next. Next slide. AI problems. Next problem. Next slide. Yeah. All right. So till now, what we have done, we have gathered different benchmarks from anyone who is asking us to create a supercomputer for them, or cluster for them, or cloud instance for them. We did a performance analysis and predicted the loads, the requirement, the hardware requirement, how many cores you will be needing, how much memory per core you will be needing, what will be your storage requirement, what will be your interconnect requirement, how parallel jobs there are. So we are speccing it. All of this analysis was done on an on-prem supercomputer. Now, in the next slide, what I'm going to show, I think you should all be expecting that, is there a comparison, performance comparison between on-prem supercomputer and cloud? Next slide. This is a little involved slide. I don't have a pointer, but I'll use the, you can look at the color-coded scheme. So lower is better, low is good, less is good here. From left to right, I'm increasing the number of MPI ranks or number of cores. I should expect the time to solution to reduce. On each of these core counts, I'm running on-prem supercomputer blue Genova 50 gig interconnect, red. Skylake 100 gigabyte, yellow. Skylake 50 gig green, and Haswell 10 gig orange. So what we are observing here is that with different choice of HPC cloud instances, we are getting different type of performances. It is expected, right? There's nothing funny here. However, the question is that which of these HPC instance you will choose. I'm assuming that you do not have an option of running on-prem supercomputer. You do not have an option of blue. Not everybody has a supercomputer. I think everybody in the room should be saying that I would use red. Next slide, please. Now what do you think? Will you use red? Red is Genova. It is costing you $9.80. Skylake is $3.90. Yellow. Will your mind change after looking at the price? Even if it doesn't change, if you're rich, you keep on using expensive thing. But the point is that cloud gives you option to choose. If this month you have less money because you travel a lot, you can choose a backslide, please. Sorry, backslide, back. I was waving and then I did not know. Backslide, please. Back. Yeah, stay here. So you have a choice to choose. So here we say expensive is not always good. It's up to you. You can have a poor man supercomputer also, and you can have a rich man supercomputer also. All right, next slide, please. Next. So based on all this analysis, here are the extreme boundaries. Some jobs will require large number of cores, some jobs will require large number of storage, some jobs will require more memory, and we find out the extreme values. Next slide, please. And find out that in order to do all of that workload, you would be needing 1,000 cores, and computational units are measured in core hours. How many cores are running for how many hours? So for this entire workload to finish once, you will be needing 2,500 core hours need to be used, storage, RAM requirement, and then after correcting for the performance of on cloud, we are estimating that all of this thing will finish in 4.5 hours. Now, the question that you should be asking at this point should be, how much will it cost? So any idea how much of this cost on cloud? Will it cost $1,000? Yes or no? Next slide, please. Oh, there was suspense, actually. Please, previous slide. Previous slide, please, previous slide. Yeah, it costed $230. Now, think about this $230. The beautiful thing about cloud is that you don't have to actually use it. If you are not using the compute, you're not paying for it. So you can spread your computational workload that I mentioned in the previous table. It involved so many disciplines. You can spread your computational workload for a week. If you finish that entire work, if your students take 1 week to do all of this analysis for learning, so this is your weekly budget. If you spread it to a month, this is your monthly budget. This is just a ballpark figure, just to give you an idea. People who have not used cloud, and they have mixed feeling that, well, cloud is very expensive. It can be mismanaged. If you forget to turn it off, you'll get a surprise with a $1,000 bill. So if you do things carefully, it's a very affordable and a green alternative. Next slide, please. So let's go through some of the basic, I have 2 minutes here, conclusions here. Hyperscalers offer sustainable computing solution. Hyperscalers are basically the big fours, AWS, Google Cloud, Oracle, Azure. cloud offers range of performance trade-offs. So on an on-prem cluster, you do not have a choice. If you just have purchased Genova nodes or A100 GPUs, that's what we have. You cannot have different. So throughout these 2 days, we learned that not everything required the fastest supercomputer. Not everything required the best hardware. So you need to have an option. Some workloads are not suitable for the state-of-the-art architectures. So cloud provides you an option. You can choose. Previous slide, please. Previous slide. Previous slide. And we also learned expensive is not always the best. The next slide, please. Next slide. Huge opportunity to optimize scientific workload on cloud. On cloud, you actually, any misuse of your computing is actually dollars. So any optimization you can do is saving money. So with this circular economy or cloud-based circular economy, you actually move away from selling the hardware to actually providing services on top of the hardware. So that's the new business model. That's a circular economy business model. Add services over there. Of course, cloud is a perfect match for certain type of throughput computing where you're running many parametric sweeps. But for a very large direct numerical simulation type of simulation, of course, supercomputers are the way to go. Next slide, please. Again, after giving all of this speech, I have to give some action item that this is not just a theory. I have been doing actually trainings, workshop for the last 2 years. In fact, we did something similar yesterday also. There was a room full of students over there. And everybody actually ran a test case without knowing Linux, without knowing parallel computing, without knowing any MPI, nothing. So we took them, and they were able to run these benchmarks cases over there. Next slide. And the last slide here, since we do not have a question and answers, what you can do is that you can scan this QR code. You can use this QR code for multiple reasons. One is just to provide a feedback, ask questions. I generally like criticism more than the praise. Praise means that you don't have to do anything more. Criticism means that you have to do more. You also use this to contact me if you are interested in actually creating a cluster for you. So I can have a meeting with you, and we can discuss about it. Students who are listening in another room, what you should do is that you should provide your email in response to this Google form. What I'm going to do is that I'm going to add your emails to my mailing list, and you'll be receiving my emails for the future workshop events. All right? I think I'm over time. I think I'm right on the dot. Thank you very much.
Thank you, Dr. Horam. Our third speaker is Dr. Ziad Nesman. He's Associate Professor for Mechanical Engineering Department, Research Center for Advanced Materials from King Fahd University. He's present title Saudi Arabia Date Palms, a pathway to sustainable product. Please join me in welcoming Dr. Ziad Nesman. Welcome.
Assalamu alaikum wa rahmatullahi wa barakatuh. Jazakum Allahu khair. Thank you so much, everybody, for coming. Bismillah ar-Rahman ar-Rahim. Let's go ahead and begin, inshallah. So while this is coming. Okay. So we got some slides up there. So Bismillah. It's really like Dr. Mahmoud just said a little bit ago. Yeah, Shabab in the back. Let's be sustainable. You can turn off your Jawal. قفل الجوال يعني ثلث ساعة إن شاء الله. Just 20 minutes give me, and inshallah, I want to give you an opportunity to maybe do some business and use your engineering and science and business degrees to do something beneficial, inshallah, for the ummah here in Saudi Arabia, inshallah. Okay, so what I want to talk about today is date palms and using them to make some sustainable projects. Okay, I'm not proposing to cut down palm trees. I'm talking about using crop residue. So what that means is the baqiya, right, the leftover pieces of the date palm tree that we don't necessarily need, to turn it into value-added products. And so what I'm going to talk about today, I took out a lot of equations. Okay, I'm going to not go off on engineering land with you guys, but I want to show you a business kind of method that I'm using to actually try to start a business here in Saudi Arabia and work with local industry. So hopefully this is beneficial. Okay, half of you don't think so, but that's okay. Bismillah, next slide, please. All right, so what we're talking about here is environmental sustainable challenge. We want to make sustainable local building materials. Okay, well, we got the challenge here. The Saudi Arabian construction projects, they're growing at an exponential rate. So fast. Okay, we see everything happening in the World Cup and everything. All of a sudden, everything's starting to explode and it's on fire, mashallah, tabarakallah, because of the 2030 vision. Construction projects right now, there's different estimates, but it's somewhere between 14% to maybe 25 or 26% even of the national budget. So somewhere around, let's say, 50 billion US dollars. So there's a lot of money in the construction industry. And of course, we're using real materials to build real houses for people. And of course, you know, when we start using real materials, that means there's going to be some kind of sustainability issue that we're going to have to source, to take raw materials and turn them into real products in the end. And there's going to be some challenges that we have. The material of choice right now is actually concrete. Okay, so we are using concrete bil-habl, right? There's so much concrete that we're using constantly because that's actually what's available locally. So that's actually really good. However, it's estimated that about 8% of global CO2 emissions are actually due to the production of concrete. And of course, it's a very water-intensive process to make concrete, and that's consuming globally something about around 10% of the water supply that we have. This is a huge problem. Plus, of course, concrete has problems with absorption and radiation. Okay, now we're talking about heat transfer. Okay, well, the last point I make there is about the importation of the construction materials themselves. Importing things, it damages the environment. Shipping, if we're talking about here, you know, boards of some kind, okay, medium density fiber board, or any kind of OSB, orientation stranded board, some kind of building materials, we're actually going to be polluting by, of course, shipping it from point A to point B. Point A may be China, point B being Saudi Arabia. And so we need to try to minimize these things. And of course, we're paying more money just unnecessarily to actually ship things. Next slide. So what's the proposed solution? Using date palm trees. And so Dr. Haq, he just spoke about this a little bit ago. He's done some of this. I'm here to say there's not really anything here that's necessarily groundbreaking and earth-shattering. It's actually using some techniques that are already available to make composites out of natural fibers. But it's something that's real and it's being done, and we can very easily do this here in Saudi Arabia, inshallah. And I'll show that we've actually been quite successful with this so far. We have over 31 million date palm trees in Saudi Arabia, mashallah, tabarakallah. And you can see that, of course, we have lots of, every year, waste that we generate. Okay, what's the waste I'm talking about? Every year, once a year, and this is actually the time of year, where you go around and you cut the saf, right? So the saf, you bring it and you cut it around. It's the crop residue branches that you cut off. It's the things that are on the ground that I'm pointing to there with the residue. That's the fancy term for it. Okay, there's a lot of trees, like I said. Click the next slide and go back. Okay, there's lots of different kinds of date palms here in Saudi Arabia. I find this very interesting from the Saudi General Authority for Statistics on Agriculture. Okay, in the region that I'm in Sharqiyya, there's a lot of khallas. That's nearly 25% of everything there. I'm personally more of a Sukkari person, which is in the middle of Saudi Arabia. But it turns out that I live in an area where there's a lot of one particular cultivar, which is khallas. And so we're going to use that one. So can we use these things as construction materials? Quick answer, yes, absolutely. We can do that. Now, next slide. And so we can do lots of things with it. And the next slide. And, you know, construction materials is what we're going to focus on today. Okay, but there's been lots of things with automotive panels. Dr. Al-Haq, he talked about a little bit about that. I know that even oil palms, okay, have been used to do the interiors of certain kinds of cars, and here's a mock-up on a Porsche, actually, for the outside. That's not from my lab. And you can make biomedical packaging as well. So we're saying we're going to extract fibers like we did here, and then we're going to make composite materials, and we've done that in the lab. And anybody wants to come up at the end and see real things we've actually made. Couldn't bring full sheets of stuff, but we have some samples here. Next. Okay, so in order to, talk about sustainability, there's really 3 aspects that you really need to address. So it's easy for me to remember because it's EASE, which is engineering equation solver, but it's also for sustainability, economic, environment, and societal concerns that you need to constantly think about and address. So the economic considerations that everybody's worried about. Now, guys, the ones that are left, this is real, okay? So this is me going around and speaking to businesses in the Dammam Second Industrial City. So this is actually real experiences that I've had talking with people that are possibly investing and that I'm starting to work with to do businesses. Everybody here in Saudi Arabia cares only about cost, okay? Just the reality right now. Yeah, we can do high tech. Personally, love the high tech. And I did most of my career doing that. But to penetrate the market here, you need to talk about cost constantly. And that's going to have 3 particular factors that are really important. Okay, the first one is, okay, you got these competitors that are already bringing in similar kinds of product, whatever that might be. Here I'm talking about maybe medium density fiberboard, which is what we're going to talk about. So it's a tough competition because why? It's coming from China already. The government in China has already figured out a lot about how to subsidize businesses and build them up. And so now we're competing against these people if we're trying to do something here in Saudi Arabia. So we have these tough competitors that we're up against. So we got to match them on price because when you're given 2 options here on the ground, okay, if you go to the souk in Dammam, the elders there, okay, the shiyukh are going to say, I'm going to take the cheaper thing every time if it has similar properties. Why would I support anything else? I'm going to go cheaper. So you got to keep that in your mind. The next pick is capital investments, okay? So we have to invest in capital infrastructure to begin with to make a lot of these products, to make real manufacturable products here in Saudi Arabia. So we got to think about that. Well, how does this kind of happen? It's probably only going to be with government intervention right now. They need to see that there's a real purpose for this, and then therefore they're going to invest in the CapEx, the capital expenditures, in order to support a specific kind of industry. And what we're talking about here is more of the composites. There's a composites industry that's alive and well, alhamdulillah, here in Saudi Arabia in general, but of course mainly it's going to be petrochemical based, as well as we're using mostly glass chopped fibers. The next one is environments, the second one. Well, obviously, if we're using some kind of real material here, we're using date palms, there's going to be less negative impact. So that's implied by actually doing anything that's sustainable, that there'll be less impact on the environment. So we're nailing that one because we're actually going to be using a residue, leftover pieces of a plant that was going to be thrown away, in a lot of cases actually burnt even here in Saudi Arabia. The last one is societal benefits. It needs to be at least the same, if not more acceptable, to the society that you're actually selling the product in. Okay, so in this case, we're talking about the date palm, a nakhil. Okay, it's native to the region. There's a high level of familiarity. Okay, so I put up one symbol here. We're used to seeing this one here on the right. And subhanAllah, look in the upper right-hand corner of the screen even, for Jamia Malik Khalid, right? Even the symbol up there, it's got a date palm at the top. So it's got this familiarity already ingrained in the people, woven in. And so we inherently are tied to it. It's also tied to our religion, alhamdulillah. In the Quran, it's arguable, but it's mentioned, the nakhla, is mentioned 22 times, okay, in different places, about Mary, the mother of Jesus, peace be upon her, who actually even held on to the palm tree and shook it. It's mentioned again and again. It's a sacred kind of tree. And there's many ahadith, the sayings of the Prophet Muhammad, peace and blessings be upon him, sallallahu alayhi wa sallam. One of them that I pulled quickly was, inna min bismillah, ashajar, lima baraka ka barakahu, I'm not good at Arabic. Barakatahu kabaraka al-Muslim. And then there's more to the hadith, but it ends with, hiya, the Prophet ﷺ said, hiya an-nakhla. It's the palm tree. So it says there's no other tree basically that has as much blessings, like the blessings even of a believer, somebody that's following God. That's the date palm tree. Okay, and that's an authentic saying of the Prophet, peace and blessings be upon him. Next slide, please. Okay, so now let's talk numbers. Okay, easy math here, all right? So how are we going to do this? Is this really possible? Okay, the current residue, that's the pieces again there that are on the ground in the picture, that's all we need, could yield something about around 30 million sheets of medium density fiberboard per year. Okay, big sheets, a 4 by 8 sheet, 4 foot by 8 foot sheets. It's like 1.25 meter by roughly 2 meters, okay, like 1.75. So a big sheet that you buy from Masdar or whatever company you want to go to. So buying something like that. So one sheet of MDF, if we do the numbers, is about 10 kilos, and then each, 31 million date palms, each one produces about 10 kilograms of waste. So, that's a lot of sheets. There's some waste here and there, and it's probably, kind of over-exaggerating a little bit, but even if it's half of that, we don't even use that much. So subhanAllah, all of a sudden, if we're doing this, we might even be able to export. And that's something big that we export some things in this country, oil and gas, but what we don't is building materials, for example. Okay, push the button again. Okay, there's an amazing initiative out there. We'll talk more about the circular economy in the panel session in just a few minutes. But that one is the Saudi Green Initiative, okay, where we're planting, inshallah, around 10 billion trees in Saudi Arabia. That's additional. There's already 31 million date palms. That's all I'm talking about. But another 10 billion trees are going to be planted in Saudi Arabia. And in the Jazira al-Arab, right, it's actually going to be 50 billion trees are going to be planted here over the next few decades, okay? So that's a lot of trees that are going up, okay? Not all of them are going to be date palms. So is it applicable or not? Well, yeah, I mean, all we're talking about here at the end of the day, out of any plant is cellulose, hemicellulose and lignin, these pieces, these components. And I'm not going to go into the chemistry too much, but it's all the same. And so we start to set up things that already are present, then we'll actually benefit from collecting the waste of these other 10 billion trees that will be there. 10 billion is, like I said, decades away, a long time. But in the near future, 600 million trees by 2030, in the next 5 years. And so if we look at the map of Saudi Arabia here, you can actually see the regions where they're actually doing this. This is from the Saudi Green Initiative, the websites there in red. And you can see the areas. So I'm from the Sharqiyya, right? I'm from the eastern province, and you can see a hot spot there, Al-Hassa, right? So this is where a lot of the khalas, date palms are. And there's a heavy effort there to plant even more of those, as well as many other trees as well. Riyadh is a hot spot, and then up in the northern borders, okay? Even down here in Jazan, there's a hot spot. Okay, and so on and so forth. They're planting trees all over the place. MashaAllah, tabarakallah. Okay, but if we do the math now again, 600 million trees, if we go back to the numbers again, that means there's going to be about 600 million sheets per year possible, or even 10 billion sheets a year once these decades go by. So this is an opportunity because we're trying to move towards a more circular economy. And MashaAllah, tabarakallah, Saudi Arabia has vision to actually do that. Then if we position ourselves, and I say we, it doesn't mean Zaid and Dr. Saad and whoever else. I'm saying, Shabab, you in the back. If you think and you position yourselves, you see what's already being done by our government here in Saudi Arabia, and you position yourself to be the receptor of some benefits and be a part of the circular economy and sustainability, you can actually benefit even financially as well. So it's there. Of course, rizquna yani maktub, okay? It's already written what's going to happen. But yeah, it's not as easy as going and getting a nice job at Aramco. It's a difficult task to go out and try to start your own business. But if you believe that what Allah is going to give you is already written, then there should be no worries. So don't worry. Do the right thing, and Allah will take care of you, right? Because, yani, man taraka shay'in lillah. Okay, I can see people responding. Go ahead. Next slide. All right. let's go back to medium density fiberboard. Is there a market for it? Oh my gosh, subhanAllah, mashallah, tabarakallah, there's huge market for it, okay? We're talking billions of cubic meters of this material being, produced every year. It's only gonna grow at a rate of about 3.7 over the next even 3 years. So maybe things are out there. This is, from some marketing research and whatever. So, okay, there's a market. We've established that. Next slide. Okay, so we can make all kinds of stuff. We can make partitions, okay? It's one of our boards there in the center. Acoustic paneling, we've started to use these things for these different things. Wall paneling, insulation, furniture. Okay, the furniture is not from us. That's actually a real piece of wood there. But you can do lots of different things with medium density fiberboard. It's used all over the place, okay? And plywood and whatnot, we can make this from it. You're sitting on it right now even. So there's reasons to actually do this, and it's all around us, whether you know it or not, even in your own furniture at home. Okay, but the one challenge there that I'm re-putting again from the E's, right? The challenges. The first one was the economic one. The environmental part, that was easy, okay? Sustainability, well, that's there. So we proved those, I think, hopefully in your minds, but it's really showing the economic viability to the people here in Saudi Arabia. It's about actually showing that we can do it cheaper than the competitors. So that's kind of where we're at, and it's a tough challenge, and I've started to have these real conversations with people in the industrial city, and I'm just saying, hey, it's a tough road ahead, but let's do it. Let's give it a shot, okay? Bismillah, next slide. Okay, now I promised you not too many equations. Okay, but I'm still a professor and I still have to do a little bit of this. So what I'm showing you here is a piece of the date palm midrib. So this is the saf, right? So you cut it near the base, the jadran of the palm tree. You cut it here, and then you can see that there's actually fibers oriented. I steal a picture of a piece of board that's cut from any tree back in the US, for example, spruce or a fir or something like that. And you can see that it has clearly a grain direction, which is longitudinal, and then there's a radial direction because there's rings, and then there's a tangential direction as well, which we label up there. So that's pretty typical for the coordinate axes for lumber, okay, for pieces of wood. But the date palm looks a little bit different, and you zoom in on it there and whatnot, and you can see there's kind of patterns, but it was always in my head now as a material scientist, mechanical engineer, is it really actually orthotropic, okay, which we're going to see this in a minute, or transverse isotropic. It's got these particular directional properties to it. Next slide. So then we took a look and we tried to characterize it in all the different directions. Okay, now we think in Cartesian coordinates. You can see my axes again there. We have the longitudinal, radial, and tangential directions. With a simple uniaxial tension, okay, I got real samples here, right? So simple uniaxial tension, pulling on it this way, right? We can actually get the different elastic moduli, okay, E11, 22, 33 in those different directions. That's piece of cake. That's pretty straightforward. After cutting the sample out of the soft, the midrib, the date palm midrib the right way. So you cut it one way, and then you rotate it along each of the different coordinate axes, and then you can pull on it. And then if you do bending tests, you can get the shear moduli. Okay, so G12, G13, G23, okay, so just from simple bending tests, okay, and we just do two like this, and then we bend it in the center, get the data from that, you can actually back out what the shear moduli are. And then using a method that's developed actually for composites, okay, composite materials, which is the off-axis tensile method, modifying that just a little bit for our purposes, we can actually get Poisson's ratio by doing calculations. But we still do more bending tests off-axis. We get that data, and then with a little bit of equation magic, then we're able to actually come up with Poisson's ratios. Okay, so we do all of this, and we get all of these values, and we figure out the numbers. We go to the next slide, and what do we see? Okay, here's the compliance matrix here. Okay, who's got the material science knowledge here? Is this isotropic or orthotropic? Who can tell me? I need help in my lab. I'm recruiting. Okay. Click the button again. So it's actually, mashallah, click the button. It's orthotropic. See above, it looks like this. And you compare it with another material like spruce. Okay, this is a tree in the US, it's a softwood, and it has the same makeup, okay? So the answer to the question is, the sciencey part here, it's actually pretty cool that it's an orthotropic material. Okay, I still have to publish papers and whatever. It's not just all business time here. So I still got to keep the research alive. Okay, next slide. Okay, now looking at this. So we're looking at the green portion now, okay, still cut in the same place. And we zoom in and we zoom in. What are we talking about here? The natural fibers that we've seen some pictures of. So we zoom in there and we see the fibrils. Okay, click the next button. And what do? Well, we need to characterize the mechanical strength, okay, next slide, by actually doing single fiber tests. So by using some standards, okay, we're using basic engineering stuff in the standards. We actually put it into the load cell. We do the tensile tests on it using the standard. Click the button again. I should have just done this probably as not animations. Click. So you get standard looking curves. Don't worry about the numbers. It looks pretty standard. You can see clearly when the fibrils are starting to break, and we can get off of this the elastic modulus, the strengths, etc. Click again, next slide. And then we do some basics. This was great. A great project for a master's student to go through and take a look at the basics of shear transfer along the interface between the fiber and the matrix itself. And so we did the experiments like this and kind of zoom in there. And so we're pulling a single fiber out of a piece. In this case, this is epoxy. And so we pull it out and then click the next slide. Off of that, we can get the actual interfacial strengths. So the interfacial strengths here, we did it for 2. Go back to the slide. Date palm mesh fibers are at the top there. It gives you an idea. The red ones are those. The blue are date palm midrib fibers. Other people have done this. I said other people have been doing this. And our results are the green. So you can see that we're actually getting similar results to other people. Some people got higher than us. Why? Chemical treatments on the surface. You can increase the bonding, so then the interfacial strength goes up. But we're trying to do it in a nice, cheap way by not using too many chemicals, mostly sodium hydroxide, which has actually got some negative environmental impacts. Next slide. Now we want to do some kind of full process. And so we've modified the process over time, and basically we're starting with a hydrothermal process by just heating it up. Putting it into boiling water, making sure that it absorbs, it actually disrupts the bonds very quickly, very cleanly, and we don't have to use a lot of chemicals. Then we use a hammer mill first, second time, and then we get some kind of residues and whatnot, but at the end, in the second hammering at least, we get some very clean fibers out of it. Next slide. And in this particular one, actually this is one of the exact samples, I think. Uses, we're using epoxy here because it's very water resistant. It's a little expensive, but what we're talking about is we need to use it for construction forms. So if you're talking about houses that are built in Saudi Arabia, you have to build forms out of something that actually holds the concrete to make the amuda, right? So you have to make the columns from something that you pour the concrete, the kharasan fiha. And so you make this out of this kinds of material. Aramco's been trying to convince local construction people, hey, use plastic. We make plastic, oil and gas and whatever. We make lots of polymers and plastic. You should use that. But the people don't like it. So again, you have to go to your customers again. And the people in the construction industry, they want to see fibers. You can't see it from where you're at. Maybe you can see that one there, but there's actual fibers in there. They're used to seeing wood. And so they want to see those fibers. So then it breaks down the barrier for them to invest and actually buy the real product in the end. And so on the back side here, we actually have, no problem, inshallah. And so you can actually do that. Just click, next slide. We actually do the mechanical test in this. It breaks in a pretty normal way in uniaxial tension. Don't worry about the numbers. We did the tests. Next slide. We're actually applying very basic theory here, the rule of mixtures theory. Click the button again, and you can see that you can model these things about the shear transfer between the fibers and the matrix for the elastic moduli. Everything falls and matches theory. Click. Great, we zoom in. Okay, click again. We went ahead and we compared to lots of different manufacturers out there for different kinds of woods, and we find that ours is very similar. Alhamdulillah. Next slide. Check. Click again. And so then we look at OSB and MDF versus us for the elastic modulus, same thing again. So we actually get very good results, and it compares to others. Okay. We've also done it for urea formaldehyde. That's these samples over here. And what we find is that our results are very similar to what you expect and actually match what the standards say you need. Next slide. Next. Okay, so we have a similar process for urea formaldehyde, and then we actually find that it's acceptable results. Click for actually the water absorption that we get, especially in the case of the higher content of urea formaldehyde. Click. I'm almost done. Click. Click. Also for increase in thickness, well, that one, click. It's not quite where we want it to be, click, so that one we didn't quite get there, but we're really close. It's somewhere around 21. We can fix that. Next. Click, 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 all the way through to the end here. Basically, you find that when we get around 12% urea formaldehyde without too many other treatments, that we actually get a good product. Okay, click into the end, guys. All right, next. That's what I had really to say. The next future for us here is to do what? We need government support. We'll talk about that in just a minute with the panel session. And Aramco's already talking about backing because we can actually use petrochemicals for this. And local manufacturers, we've been talking to them and we got customers on the backside. Jazakallahu khair, wa barak fikum. Assalamu alaikum wa barakatuh.
Thank you, Dr. Ziad. Our final speaker in the plenary sessions is Dr. Wael Ahmed. He's founder of CTO, Plenary Systems, Professor of Mechanical Engineering, University of Gulf, Ontario, Canada, and his present titles Innovative Multi-Phase Flow Solutions for Sustainable Energy, Water and Flow and Water and Food Systems. Please join me to welcoming Dr. Wael. Welcome, Dr.
I've been told to only spend 10 minutes for my presentation, so assalamu alaikum. I'd like first to thank the organizing committee for the invitation and the nice hospitality. I have a small message actually to share with you today in my presentation, and maybe the 10 minutes will be enough for that, but I will show you some samples of what I was talking about in the panel in the morning. So if you please bring the slides. Next slide, please. So those are my key talking points. So I was planning to actually talk about like multi-phase flow importance in sustainability and how can we use the analysis that I'm going to share with you today in order to basically push sustainability in the right direction. And I agree with Dr. Zaid when he's talk about like it's very nice to keep track of the cool technology, but it's always nice to actually step back and stop and think about like what we have in terms of low-hanging fruits in order to improve our efficiency. So I don't see the slide, but okay. So I started working in the aerospace industry back in 2001, working on scavenging line for oil and gas in aero engines. And then I joined the nuclear industry for a few years, looking into improving the, again, so the 10 minutes is not gonna be my fault, but let's share with you like a very important chart here that is basically shared by the energy agency about like, the efficiency in terms of sustainability. So if you look at the different sources of energy around the world globally, you will see that by 2030, we have, if you click one more button here, so 40% of the total energy in the global world can be saved if you look back at the efficiency of existing system. So if you look at any system that you think of, you actually look back into the design of this system, the modeling of this system, you will see a lot of potential of energy saving. So you can imagine now in 2030, 40% of the total global energy use can be saved if you actually improve efficiency. That's why most of my research is actually looking into how can we improve efficiency in different systems. So if you click next. So that's why I'm going to share with you a few examples here very quickly on different projects I have been involved with. Someone related to energy, someone related to water and food application. Next, please. The first project was basically pushing, when I was working for atomic energy, you would like to push the efficiency of steam generators. But the problem when you start enhancing the flow rates in steam generator, you start getting to a degradation mechanism that is affecting the material, affecting the heat transfer, affecting the fluid mechanics. And it was very hard to actually predict those performance looking into the control volume analysis that all classical system is designed. So steam generator in the whole world is designed back in the 50s, and they still use the same kind of design methodology and design models. But looking into the system and closely and understanding, maybe some interaction between the gas and liquid inside, for example, the steam generators, you can see here some of the slides showing gas and liquid steam, in the header of steam generator. By actually looking into this interaction and material relationship with the corrosion, you can actually improve efficiency by looking into how to do the analysis for this system by integrating multi-phase flow analysis. Go next. In this project, we looked at how the two-phase flow interact. How can we actually develop a methodology around pushing more like liquids in order to enhance efficiency steam generator, but at the same time keeping the degradation level to the minimum. And that's why we had to do what we call it the multi-phase flow analysis, looking into the gas-liquid interaction, but also see the effects and impact on what we call it the flow-induced vibration inside these steam generators. So you're actually pushing the limit of the operation of the steam generator, but at the same time protecting the safety of these steam generators. I'm actually running here, so if you go next. So we did this actually in the steam generator header, but also we did this in the elbow around the exit of a steam generator in order to make sure that we are still in the safe zone for these analysis. Go next, please. Other application, I was mentioning that using a lot of classical traditional system is water and wastewater application. When you have sludges, you have gas, liquid, and solids in the system, and most of these systems actually are very inefficient. So you can imagine 45% of the total world energy are consumed in water and wastewater applications. So if you're able to save a little bit on this amount of energy, you can save a huge amount of power generation. But when you look at this system, most of the design guidelines are relying on control volume, thermodynamic analysis, average property inside this system. So without looking into multi-phase flow analysis, without looking into tracking, I think you went to the second step, without tracking all these particles, particle motions, gas, liquid, solid inside these phases, it was very hard to actually come up with a much better efficient solutions. So that's why multi-phase flow analysis is very critical and very important. In this slide here, you will see we start adapting some of the AI technology in order to track these particle sizes, bubble sizes, so you can actually correlate mass transfer, heat transfer, as well as fluid dynamics property in order to find out better heat transfer models or even better pressure drop models as well. Go next. So I mentioned in the panel discussion today, the most important emerging technology utilizing AI, not only digital data, but as a mechanical engineer, we see a lot of potential for predictive tools that we can actually use AI with available smart sensors. So we can actually integrate these two. We call it the digital twin application. So we can actually make a prediction of what's going to happen in the system. So in Canada now, we have been actually pushed to adapt the digital twin in many applications. So we see a lot of potential for example, agriculture. When you have a very complex system, when you have a much complicated interaction between different type of system, biology, water, heat, mass transfer, all these kind of analysis, AI will give you the power to make the analysis of these data, bring all these data together, to try to actually predict what the system will perform, how the system will perform next. And then instead of actually reacting to the system performance, you actually do be proactive in order to determine the efficiency of this system before you actually get to the problems. Next. I think we'll just skip this one here. Next, please. So what we did, and I've done this over the last 10 years, every time we develop technology in the lab, we try to see some kind of opportunity to develop the product out of this technology. So far, we have a couple of products in the market now. The first one is, we call it the Flu Move. So I started the company about 3 years ago. Of course, the university, also the government, actually putting a lot of effort in order to support this type of initiative. So this product now in the market for fish farms. We see a lot of also application in wastewater coming in around using multi-phase flow analysis that we develop in the lab. We have multiple other products coming in the next few years. This is just a sample of these products that we have so far in the lab. Go next, please. Next. Time is over, or yeah, okay. So this is another technology that we develop, and I mentioned to you, integrating different systems. So sustainability is not always like, within a system. You have to really look at, a process innovation. So if you have, for example, CO2 production out of an energy, cycle or an energy system, you can actually use this CO2 in order to enrich water in greenhouses. So we do like what we call it the reuse of the CO2. Utilization in a different term, but without looking into the innovative process by integrating these two systems, you'll not be able to do that. So this is another technology coming in the market in 2027, and it's basically helping farmers to increase yield in their greenhouses by utilizing CO2 emission from diesel generator that is used for power generation or for heating application. Try to utilize this CO2 into greenhouse application for growing plant faster as well. Next, please. I think we discussed these key points in our panel session in the morning with Dr. Javid, so I will skip this one here and go for the final slides. Next, please. So I have to thank, of course, the team I'm working on. So all these projects have been, involve a lot of young engineers and researchers. So actually, 2 of these students are Saudi. They are finished and they are back now into, the Saudi market. One of them in the university as well. So next, and definitely most of these projects and application cannot be even done without research support. So those are the research support that I received over the last 10 years. And the next will be the last slide. The key message for this presentation today is, before you actually rush into adapting new technology, getting cool tech integrated in the system, first think about how can you improve the efficiency of existing system by unlocking opportunity for system that was not designed, system that has multi-fluid, multi-phase type of analysis, but never been designed using this analysis, used by thermodynamic analysis. So rethink about improving this model first, improving efficiency, and then go for the next technology adoption after that. Thanks, and I hope I stayed in the 10 minutes.
Thank you, Prof. Wael, and thank you to all our speakers for their valuable presentation. We will now proceed to the panel discussions titled Enabling Circular Future, Smart Technology and Resource Efficiency. With Professor Saleh Al-Shehri and Professor Roh Kuram, also with Ziad, Professor Ziad Nisman, Professor Mahmoud Al-Haq, and moderator with Professor Abdullah Nasser Asiri. Please join me to welcoming the name of the panelists. Thank you.
Good afternoon, everyone. Welcome to panel discussion 5. We are here to explore how smart technologies and circular economy practices can shape more sustainable future. Before we begin, I would like to extend a warm welcome a warm welcome to our speakers and thank them for joining us today. With us today is Prof. Salih al-Shehri, Vice President for Research and Industrial Development at the Royal Commission for Jubail, Kingdom of Saudi Arabia. Also, we welcome Prof. Ruh Quram, Computational Scientist at KAUST, Kingdom of Saudi Arabia. Joining us as well is Dr. Ziad Lizman, or Zaid Lizman, Associate Professor of Mechanical Engineering at KFUPM. And finally, we are honored to have Prof. Mahmoud Al-Haq, Professor of Structural Engineering at Michigan State University. Our first speaker is Prof. Salih al-Shehri, who will discuss how smart technology can enable circular value chains. Prof. Salih, the floor is yours.
Thank you, Dr. Abdullah. Bismillah ar-Rahman ar-Rahim. I think we could agree on that the economy, in fact, is one of the main driver for the smart technology. I mean, the smart technology by itself is no use unless if it is contributing to the economy and circular economy in particular. Smart technology, you know, it's a lot of smart technology we have, like Internet of Things, like digital twin, AI, blockchain, and many of these. They are all together, or part of them, some of them can contribute together to better circular economy. But the thing that I want to emphasize in here is that this smart technology, we must use them smartly. And I think through these 2 days, our colleagues here emphasize on this one. It is not just jump and use the smart technology without thinking how to use it. And even I'm engineer, but I don't like, but I focus on research. So engineering solution by itself is not always enough. Research must be applied and continue doing better smart technology. And probably it has been mentioned many times that, and even Dr. Anas Al-Haji yesterday was talking about, for example, electrical vehicles. Now, when we think about electrical vehicles, do they reduce the carbon emission? I don't think so, because instead of having distributed in the city, we are just moving or shifting the fuel burning outside the city. So we have to smartly think about how to use them. Do we just use them in buses and trucks and big cars, or what to do? So we have to be smart when we use smart technology. Other example for the solar energy. We all like the solar energy because it's clean and free, I would say, but we have to think about its efficiency. And we were talking, our people here, yesterday was talking about that the Saudi Arabia is, we have enough land, we have enough sun, but also we have enough, unfortunately, dust. which degrade the use of solar energy. Another problem also is the heat, the high temperature. High temperature degrade the solar panel or solar energy production. So is it wise to use solar energy in Saudi Arabia and Gulf countries, or do have to do something about it? Still here, I'm saying that research still continue. We should not just go and run and just pick up this technology and try to use it right away without thinking. The last thing I want to emphasize on is that I think Professor Hamid yesterday was talking about in Saudi Arabia, for example, 70% of the electrical energy we produce in the country are used in cooling houses and buildings. So this is a huge quantity of electrical power. So if we want to do a lot of research and reduce the power consumption, which contribute to the circular economy, we should focus on things that we can contribute on. For example, if the 30%, the other 30% are in the transportation and maybe lights and other things. But if we do research on that the other part, for example, in transportation, if one of the professors did good job in research and reducing for example, the power consumption, the fuel consumption in an engine, who's going to benefit from that? Probably Toyota and Ford and some other companies. But if we focus on reducing the energy we consume in our houses, doing research, we are talking about 70%. And the house itself is, I would say, Saudi product completely, because the designer is Saudi or Saudi company, the material, cement, steel, glass, are all produced in Saudi Arabia. So this is a complete Saudi product. Then we should focus on the research on this area. I have a lot of thoughts about this thing, but we can't communicate with anybody if interested to go investigate more on this. Thank you.
Thank you, Prof. Saleh, for those insightful points. We now move to our second speaker, Prof. Mahmoud Al-Haq, who will talk about designing products and systems for circularity. Please go ahead.
Shukran. Thank you again for having me here. A few minutes back I presented on this topic. One of the things I talked about was from the inception itself, from the beginning itself, having a thought process for design of inspection, design for circularity, not after the fact. For example, you have a bumper of a car. Oh, I have an accident. Only the right part of the bumper is broken. Why should I change the whole bumper? Can I cut it open? Can I put an epoxy and fix it? After the fact, it's going to waste more resources and be detrimental to circular economy. What if we have a consolidation of parts in the bumper? Bumper itself is made of 8 different parts by design, so that you can only replace parts of them. So the thought process, and that is where the world is going into, from the very beginning itself, if you think of, can I have low cost design for inspection, design for maintenance, and then design for recyclability. If you start from the very first basis in that aspect, then life becomes very, very easy. Second thing is the more difficult one, and Jazakallah khair, Dr. Saleh, is sometimes we have to change the hearts before we change the minds. We are used to a certain system. For example, if you go and tell a cement plant that you are causing 10% of the global greenhouse emissions, and we would like to replace that with existing pozzolanic ash or some other iron ore waste as a replacement for cement, you're going to get a pushback. But the hikmah of our Prophet ﷺ to show the path through a moderate ground, for example, using a combination of materials to show that there is a path of benefit that leads to smarter technologies and newer technologies. Israf in every way is prohibited in our religion. So by default, I tell people back in America that Wallahu la yuhibbul musrifin, Allah does not like the people who are wasted. So in Islam, by default, we have circular economy. We cannot waste anything. So when we have that attitude towards the way we steward, we as Khalifa of the world, we think of things, our vision is different than others when it comes to use of resources. Even if you are in a lake full of water, be careful of how much water you use for doing wuzu. So there are examples like that. So now coming back to your question specifically is integration of technologies from conception to the end, and then a behavioral mindset change, a societal mindset change, especially when you come from the West and the materialistic world where everything is in excess. It's a very big change to say, look, you can't waste things that even though you have it in excess. And that is the second part. Third part is more important, and the final part I would like to talk about is the creation of the future STEM leaders. If we are not, and we are in a university with students here, and the students need to think of their students and their kids and their grandkids. If you want to make a change, then you have to start when they are very early. Good habits of not wasting stuff, designing everything from your daily routine to materials to food to everything should be in mind that you are leaving the earth in a better place than you got to. So these are the three things I would like to leave behind. Jazakallah khair.
Thank you, Prof. Our next speaker is Prof. Ruh Quram, who will share how data-driven approaches can optimize resource use. Please, Doctor, you may begin.
Okay, thank you. So that's easy. Data is heart of any decision making. If you can measure, you can manage. If you can measure, you can do analysis. If you can measure, you can make prediction. Data is ingested in any AI pipeline, so that's easy. However, I want to point to the fact that Saudi Arabia is positioning itself as the third largest AI hub in the world. It's something we should all be proud of. It's something we should all embrace. At the same time, we need to be careful that this means huge amount of new resource utilization. So during my presentation, actually, you talked about changing heart and mind. I'm actually I'm operating Shine supercomputer. I'm actually benefiting from on-prem computing, but I'm thinking that, is this the right way? And I'm in my study and in my research, I'm beginning to think that sharing the resource at a national and even at an international level is very important. AI utilization is predicted at a pace of 12% yearly. That's quite a bit of increased utilization. So what needs to be done for that? Changing the hearts and mind, at my level, all I'm doing is doing training and education at universities and school level. So if I'm trying to teach the young generation that don't think of a supercomputers as a hardware that you're playing, think of it as a software utilization. So just stay in your browser, ask your question, and you should get your answer. To me, this is a better way of doing the future computing. Thank you.
Thank you, Prof. Khoran. We now move to our final speaker, Dr. Zaid Lizman, who will address the policy framework for a smart circular economy. Please, Doctor.
Jazakallah khair. Bismillah. Okay, so the last three, my colleagues here, they talked kind of on a micro level about how things would apply down at the lower level. But this whole, question of policies and whatnot is a macro level thing. So now I'm looking at kind of the high level and what needs to happen as a society, as a government, as a country, and so on and so forth, and how we can stimulate things for the smart circular economy. Couldn't agree more with Dr. Saleh, of course, about we need to be smart when we apply it. And Dr. Mahmoud, you said that, alhamdulillah, we're Muslim, right? And we should look at it from that perspective. And the religion, it's there, and it has everything that we need to really live and survive. Okay, so what does that mean? Where are you going with this? Inna ja'alna fil ardi khalifa, right? So we made you guys, okay, and again, I'm talking to the shabab in the back, you guys should be listening. You guys, we're the stewards, we're taking care of the earth. And Allah says in the Quran, لِنَبَلُوَكُمْ, right? We are testing you, and again, how you're going to use the resources that you're given. How are you going to do everything with what you've been given by Allah Azza wa Jal? It's just a fact, okay? Okay, but Dr. Zaid, it doesn't tell me about engineering and forces equal to masses, acceleration and whatever. No. What I'm actually saying is now on a macro level again, we need to view the things that we do through the lens of Islam always. And remember that. لا تنسوا نحن مسلمون. We don't ever forget where we start. We do that and Allah will make us successful. Bismillah. Okay, so what's the point here? Okay, so what drives us in our decisions as human beings? Money, power, fame, a'udhu billah, these kinds of things. That's generally what we're talking about, especially in the West. Okay, I'm from America and I can say these kinds of things and whatever. But it's rare to hear a person say ethics, religion, and these kinds of things. But that's actually maybe a better way, more responsible way. Because if I'm being driven by economics only, then I'm forgetting about everybody else and I'm easily pushing everybody else to the side. But if I use my ethics, I use my religion, I use these things to focus what I'm doing, that's going to drive a smart circular economy. So we have to do those things, but usually it comes from above, from our leaders. So economic models for this, they have to do things, right? We need to address climate change. We need to address biodiversity and pollution. Okay, that's not in the purview. That's not in front of the people on a daily basis. I'm just worried about going to work, making my money, and going home. I'm not worried if I pollute. If I roll down my window when I'm driving down the road to Riyadh and I throw out trash. Okay, but you're Khalifa, you're right? You're supposed to be taking care of things. So it takes, at the micro level, us to change and think about these things in order to make a bigger change at the macro level. But of course, governments need to get involved in these kinds of things and give goals and whatever. There's a really great report by the MacArthur Foundation talking about circular economies. So they lay out big, high-level things and whatnot, but it's worth talking about the 5 goals that are laid out that are actually following the UN, the United Nations Sustainability Design Goals, so the SDGs. So the first one is stimulate design for a circular economy, just like Dr. Mahmoud was talking about. You have to design it in from the beginning. So as an engineer, it's not like, okay, I'm just going to keep designing like we've always done. No, we need to go back to the beginning and ask the questions, why did we design it that way? Well, at the end of the lifetime, do we throw it away or can we reuse it again? This is the circular economy. It needs to be constantly pumped back into the system again. Goal number 2 is we need to think about managing resources to preserve values. Okay, that can only be done at government level. Okay, it needs to be actually done to say we're going to reserve these resources to use later in time. Okay, so they need to set things aside because they're responsible and they see the bigger picture and they can guide the people on this daily level and try to refocus things. Number 3, we need to make the economics work. This is the government incentivizations I was talking about just a little bit ago. The government needs to step in and say, hey, you know, maybe we don't need to import everything. We should, import everything. We should actually be generating everything internally and taking care of it. But we can only do that by making economic things happen, meaning we need to incentivize, cover capital expenditures for things internally, and then we need to stop exports or to tax them some way. Almost done. And then we need to invest in innovation. That's easy. That's you guys, okay? That's coming up with new inventions and whatnot. And I think that's pretty clear. And then we need to collaborate together. We do. This is an amazing forum that we have today. Jazakumullahu khair for inviting everybody to this forum. I thank you again for your diafa, for your hospitality. But we have people from all over the planet here trying to work together to meet sustainable goals. It's a great example, but we need to continue even after it. As we make real products, we need to work together, share information, and work together to get to these goals.
Thank you, Dr. Zaid. Ladies and gentlemen, this brings us to the end of our session. On behalf of the organizers, I extend my appreciation to our panelists for their valuable insights and to the audience for their active engagement. Thank you very much.
Thank you so much. Now I ask the plenary speakers, Prof. Weil also all of you, and Dr. Saeed, the Dean of our college, to join us on stage for recognition. وين ما أدري.
Profile, please come to the stage and please apologize us for forgetting your name. Sorry.
بسم الله. بسم الله الرحمن الرحيم. معالي رئيس جامعة الملك خالد الأستاذ الدكتور فالح بن رجاء الله السلمي، أصحاب السعادة، ضيوفنا الأعزاء، السلام عليكم ورحمة الله وبركاته. في هذا الحدث العلمي المتميز وبرعاية صاحب السمو الملكي الأمير تركي بن طلال بن عبد العزيز أمير منطقة عسير ورئيس هيئة تطويرها، نلتقي اليوم لنسدل الستار على ختام أعمال مؤتمر الحلول المستدامة للطاقة والبيئة 2025 الذي احتضنته جامعة الملك خالد على مدى يومين حافلين بالمعرفة والنقاشات المتخصصة وورش العمل النوعية التي تناولت مستقبل الطاقة والاستدامة وإدارة البيئة، وبمشاركة واسعة من الخبراء والباحثين من داخل المملكة وخارجها، دعما لتحقيق مستهدفات منطقة عسير ورؤية المملكة 2030 نحو بيئة مزدهرة واقتصاد مستدام وتنمية متوازنة. لقد شهد المؤتمر ثراء معرفيا لافتا تناول أحدث التوجهات في تقنيات الطاقة المتجددة والتأثير البيئي وإدارة الكربون ومعالجة النفايات وتطبيقات الذكاء الاصطناعي في الطاقة، إضافة إلى محاور تدعم كفاءة الموارد وتعزز التكامل بين الجهات الأكاديمية والصناعية نحو رؤى مستقبلية تدعم مسيرة الوطن نحو الاستدامة والابتكار. وانطلاقا من أهمية مخرجات هذا الحدث العلمي، يسرنا في هذه اللحظة دعوة سعادة رئيس اللجنة العلمية للمؤتمر الدكتور سعد بن فهد آل جبار لتقديم التوصيات الختامية التي تشكل حصاد هذا المؤتمر وتعد مرتكزاً عملياً يدعم المبادرات المستقبلية في مجالات الطاقة والبيئة، فليتفضل سعادته مشكوراً.
بسم الله والصلاة والسلام على رسول الله. معالي رئيس جامعة الملك خالد الأستاذ الدكتور فالح بن رجاء الله السلمي، أصحاب السعادة، الضيوف الكرام، اسمحوا لي أن أتحدث باللغة الإنجليزية. It's a great honor to stand before you today on behalf of the scientific and organizing committees at the conclusion of Sustainable Energy and Environmental Solution Conference 2025. Over the past 2 days, this conference has brought together leading scientists, industry experts, policy specialists, and young researchers to discuss emerging trends and solutions in sustainable energy and environmental innovation. On behalf of the scientific and organizing committees and the College of Engineering, I would like to extend my deepest gratitude to His Excellency, the President of King Khalid University, and the Vice President for Scientific Research and Postgraduate Studies, and also the Head of Scientific Publishing Administration. My sincere appreciation also goes to all distinguished speakers and guests, panelists and session chairs, all participants, researchers, and attendees. Also, my team, the scientific committee and organizing committees. And finally, our exceptional volunteering students whose commitment, discipline, and energy reflect on the bright future of King Khalid University. To all of you, your efforts have shaped the conference into a meaningful platform of scientific exchange and innovation. Now, I will read the final recommendations and remarks of this conference. So, as we conclude this scientific gathering, it's my privilege to present a final recommendation of SEESC 2025. These recommendations are derived from the rich discussion in plenary sessions, panel debates, research presentation, workshops, and poster exhibitions. They represent a collective vision for advancing sustainable energy and environmental solutions in alignment with national and global priorities. Final recommendations. Number one, accelerate national adoption of clean and smart energy systems through expand research and development and pilot projects in hydrogen, renewable energies, AI-driven energy management, and smart storage technologies to support the Kingdom's net zero strategies. Promote integrated renewable systems such as solar, wind, wave, and hybrid microgrids to enhance national grid stability and reliability and stability. Recommendation number two, strengthen carbon management and circular economy pathways through advanced technologies and policies for carbon capturing, utilization, and storage, and support industrial scale demonstration projects. Also, encouraging innovation in waste to resource systems, including circular hydrogen, industrial waste, and sustainable material recovery. Number three, enhance environmental monitoring and ecosystems protection through expand research and environmental impact assessment, pollution remediation, and nature-based solutions, especially in arid regions. Also, supporting national programs for restoring mangroves and post-fire landscapes based on scientific monitoring and biodiversity indicators. Recommendation number four, promote water sustainability and advanced treatment technology through investing in scalable innovation such as fog water harvesting, desalination energy integration, and eco-friendly filtration material, and encouraging circular utilization of desalination brine for production critical minerals such as lithium, magnesium, and agricultural fertilization. Number five, drive innovation in sustainable material and green chemistry by supporting development of biodegradable plastics, nanomaterial for energy, and green corrosion derived from local plants and natural resources. Number six, enabling cross-sector collaboration and knowledge transfer by creating national clusters linking university, industry, and government to accelerate the research outcomes. Finally, align all effort with the Saudi Vision 2030 and national research development innovation priorities, ensuring all emerging research directions contribute to energy, environmental protection, industrial sustainability, and human capability development. So, finally, this conference has demonstrated that universities, industry, government, and the research community can come together to shape a cleaner, more sustainable future. The outcomes presented today are not merely academic recommendations, they are actionable directions that can guide future projects, policies, and innovations. As we look ahead, we remain committed to strengthening our role as a hub for scientific excellence and social impact in alignment with Saudi Vision 2030 and national RDI priorities. Thank you all for your contribution, presence, and commitment. We look forward to welcoming you to future editions of this conference and to building on the momentum created here. Thank you.
نشكر سعادة الدكتور سعد بن فهد الجبار على تلك النتائج والتوصيات. أيها الحضور الكرام، وبهذه المناسبة نستأذن معالي رئيس جامعة الملك خالد لتكريم أفضل ملصق بحثي للمؤتمر وأفضل ملصق بحثي للمعرض الهندسي وكذلك شركاء نجاح ذلك المؤتمر، فليتفضل معاليه على المنصة للتكريم. وحرصا من المؤتمر على إبراز التميز البحثي وتشجيع المشاركة العلمية، قامت اللجنة العلمية بإجراء عملية تقييم متكاملة للملصقات العلمية المشاركة وفق معايير منهجية دقيقة وقيم المساهمة العلمية في مجالات الطاقة والبيئة. واستنادا إلى تلك النتائج وتلك التقييمات، يسرنا الإعلان عن الفائزين بجائزة أفضل ملصق علمي لهذا المؤتمر. الجائزة الأولى بعنوان الملصق علمي تقييم إنتاج الوقود الحيوي من الأحماض الدهنية باستخدام محفزات أحادية وثنائية المعادن المدعومة على الفحم الحيوي من نواة التمر. الباحثون رهف الحربي، الدكتور خورشيد أنصاري من جهة كلية الهندسة قسم الهندسة الكيميائية، فليتفضلون مشكورين. الجائزة الثانية بعنوان نهج مبتكر للإنتاج الميكروبي المستدام للبلاستيك الحيوي، والناشرون هم روان القحطاني، الدكتور ياسر مصطفى، والأستاذ الدكتور سعد العمري من كلية العلوم قسم الأحياء، فليتفضلون مشكورين. أما الجائزة الثالثة فكانت بعنوان استغلال المخلفات الزراعية المحلية لتصميم إلكترولايت ذكية ومستدامة للبطاريات القابلة للبرمجة كيميائيا. وكان الباحثون الطالبة آلاء أبكر من ثانوية الدرب الأولى بإشراف الدكتور محمد موسى القحطاني من كلية الهندسة قسم الهندسة الصناعية. وأما الآن نرجو من سعادة أعضاء لجنة التقييم الصعود على منصة للتكريم، وهم الدكتور باسم العلوان من قسم الهندسة الكيميائية، الدكتور سعد عوض القحطاني من قسم الهندسة الصناعية، من قسم الهندسة الكهربائية، الدكتور عبد الله الأسمري من قسم الهندسة المدنية، وفي إطار تعزيز دور طلبة الكلية في مسارات البحث والابتكار، شهد المؤتمر فعاليات المعرض الهندسي التي قدم خلالها طلبة كلية الهندسة عدداً من المشاريع التطبيقية المتميزة تعكس مستوى المعرفة والابتكار في مختلف التخصصات الهندسية. ويسرنا الآن الإعلان عن أفضل مشروع تخرج في كل قسم هندسي تقديراً لجهود الطلبة تميزهم في البحث والعرض والتطبيق. نبدأ بقسم الهندسة الميكانيكية. المشروع الفائز بعنوان تصميم وتطوير مواد مركبة مبتكرة للأطراف الاصطناعية العلوية المطبوعة بتقنية ثلاثية الأبعاد بإشراف سعادة الدكتور علي راجحي. الطلاب تركي سالم، ظافر عبد الله علي، محمد أحمد، محمد عبد الله. نرجو من الفريق التفضل بالصعود لاستلام الجائزة. ننتقل إلى قسم الهندسة الكهربائية. المشروع الفائز بعنوان نظام ضمان جودة الطاقة، وذلك بإشراف سعادة الدكتور سعد بن فهد الجبار. الطلاب هم بندر الشهري، ترك الشهري، مهنا أسامة، عبد الوهاب بن عتيق. ندعو الفريق التفضل للصعود واستلام الجائزة. قسم الهندسة الصناعية. كان المشروع الفائز بعنوان الصيانة التنبؤية باستخدام نموذج التعلم الآلي وتحليل بيانات المستشعرات، وذلك بإشراف سعادة الدكتور محمد العوض. الطلاب ياسر صالح، عبد الله الناصر، عبد الله العمري، نواف عسيري. يلا يلا شباب، اكثر واحد اشغلني في التدريب. يلا 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 تفضل. ننتقل إلى قسم الهندسة المدنية. المشروع الفائز بعنوان تصميم ممر ذكي للحد من الضباب وتحسين الرؤية المستدامة في منطقة عسير، وذلك بإشراف سعادة الدكتور عبد الله فايز الأسمري. الطلاب مشاري الحرقان، فيصل القحطاني، حمد الحبابي، حسام القحطاني. ننتقل إلى قسم الهندسة الكيميائية، والمشروع الفائز بعنوان إنتاج البوليثان على الكثافة بنظام استخلاص محسن، وذلك بإشراف سعادة الدكتور إلياس خان. الطلاب هم محمد دهل، وليد عسيري، ياسر الأحمري. أيها الحضور الكرام، لا يكتمل نجاح أي فعالية بهذا الحجم دون جهود كبيرة تبذل خلف الكواليس، ودون دعم مستمر من الجهات الشريكة التي أسهمت في إنجاح هذا المؤتمر تنظيميا وتقنيا ولوجستيا، التي كان لعطائها الدور الأكبر في ظهور المؤتمر بهذه الصورة المشرفة. نتقدم لهم جميعا بخالص الشكر والتقدير على ما قدموه من دعم وجهد وعطاء. يسرنا أن نتقدم بتكريم الجهات التالية، وهم سعادة المشرف العام للإدارة العامة للاتصال المؤسسي الأستاذ الدكتور مفلح القحطاني، فليتفضل مشكورا. سعادة عمادة شؤون الطلاب الدكتور سعد القحطاني، فليتفضل مشكورا. سعادة عميد عمادة الخدمات الإلكترونية الدكتور حامد القحطاني، فليتفضل مشكورا. وحدة المؤتمرات والندوات العلمية سعادة الدكتور عبد اللطيف المحسنة، فليتفضل مشكورا. الرجاء من جميع الطلاب الجلوس كرما. المدير العام للإدارة العامة للمرافق الأستاذ محمد الأسمري، فليتفضل مشكورا. ينوب عنه المهندس حسن خيري. المدير العام للإدارة العامة للأمن الأستاذ طلال الرحلان. المدير العام الأستاذ هاني الزهراني، وينوب عنه الأستاذ طلال الرحلان. ثم الآن تكريم اللجنة العلمية والتنظيمية للمؤتمر، فليتفضلون مشكورين. The Scientific Committee and the Organization Committee, please come to the stage. والآن تكريم المنظمون من الطلاب والطالبات. نشكر معالي رئيس جامعة الملك خالد على تشريفه ورعايته هذا المؤتمر، وبهذا نصل وإياكم إلى ختام فعاليات هذا المؤتمر الذي أكد أن جامعة الملك خالد كانت وما تزال منصة رائدة لإنتاج المعرفة ومحركا داعما للابتكار وشريكا فاعلا في تحقيق مستهدفات منطقة عسير ورؤية المملكة 2030 في مجالات الطاقة والبيئة. ختاما، تتقدم اللجنة التنظيمية والعلمية بالشكر والتقدير لجميع الباحثين والمتحدثين والرعاة